Hello there and welcome to Just About Earth, the little corner where science slows its breathing, curiosity settles into a comfortable chair, and the story of our planet is allowed to unfold without hurrying anyone along. Tonight, our attention drifts toward a place most people imagine in shades of gold and white. A place of heat, shimmer and long horizons, of wind-shaped dunes and skies so clear they seem almost polished. The Sahara. Vast, dry, and to modern eyes almost permanent in its character, as though it has always been exactly what it is now and always will be. But that is the trick landscapes like to play on us. They stand still long enough for a human lifetime, and we mistake stillness for permanence. We look at a desert and assume it has always belonged to sand. We look at emptiness and imagine it has always been empty. And yet the Sahara has kept one of the most remarkable secrets in Earth's recent history tucked beneath its dunes. There was a time, not unimaginably far back in the grand sweep of prehistory, when enormous stretches of this now arid expanse were green. Not metaphorically green, not the sort of green one might use in a brochure to suggest optimism, but genuinely green. There were lakes where today there is dust, rivers where now the land cracks in the sun, grasslands, wetlands, shrubs and trees. Herds of animals moved across regions that are now too dry to support them. People lived there too, fished there, hunted there, left their tools and their art and the quiet traces of ordinary lives in places that today seem almost impossible for such lives to have unfolded. It is one of those facts that feels, at first, slightly impolite to the modern imagination. Hippos in the Sahara, crocodiles in the Sahara, human communities living beside broad bodies of water where there is now only sand and stone. It sounds less like geology and more like someone has mixed up their continents. So let me ask you something before we wander any farther into this vanished world. Where are you listening from tonight, and what does the land around you look like when it rains? Does the pavement darken and shine? Do trees suddenly look more alive than they did an hour earlier? Does the smell of wet soil rise up in that unmistakable way that makes the whole world feel briefly reset? It is a curious thing, rain. A few good years of it, and a place can begin to transform. A few thousand, and the transformation can be so complete that future generations look at the result and can barely imagine what came before. That is part of what makes the old Sahara so fascinating. It reminds us that landscapes are not fixed identities. They are negotiations between sky and ground, between sunlight and moisture, between time and living things. And if this sounds like the sort of quiet journey you enjoy, the kind where science and deep time sit down together and speak in calm voices, I'd be very grateful if you gave the video a like, perhaps subscribed, and stayed with me for the rest of this story. It helps this slow-moving little project find other people who might enjoy ending the day with a planet-sized mystery. I do hope, of course, that the subject is soothing enough to help you unwind rather than so intriguing that you find yourself at 2 a.m. reading about prehistoric lake sediments with a look of mild determination on your face. But if that happens, at least it will be for a very good reason. Now, when most of us picture the Sahara, we picture a kind of overwhelming dryness. We imagine rolling dunes, bare rock, relentless light, and stretches of terrain that seem almost stripped down to the bones of the earth. That image is not wrong exactly. Today the Sahara is the largest hot desert on the planet, sprawling across North Africa and spanning an area so immense that it is easy to forget it contains many different kinds of desert within it. Not all of it is sea-like dune field. There are gravel plains, rocky plateaus, mountain massifs, salt flats, and wide open spaces where the wind has polished the land into something severe and almost lunar. Some areas do receive a little rain, some are harsher than others, but the broader reality remains one of scarcity. Water is rare, plant cover is limited, and survival requires adaptation at every level, whether one is a lizard, a camel, a shrub with roots reaching down into the memory of wetter seasons, or a human trying to cross it with enough supplies and better judgment than optimism. Because the desert is so large and so visually forceful, it tends to dominate our sense of what North Africa is and has long been. We forget, perhaps because our own lives are short and our maps are static, that climate is not a background detail. Climate is an architect. Move the reins, and you redraw the boundaries of possibility, shift wind patterns, change seasonal heating, alter the strength of a monsoon, and the world below begins to rearrange itself. Lakes fill, rivers connect, grasses spread. Then, under different conditions, they retreat. Shorelines shrink, soil hardens, dust rises. The same region can support a mosaic of life in one era and become dauntingly dry in another. Earth's surface is not a still photograph. It is more like a long film in which the scenery keeps changing between scenes, except the changes are usually slow enough that no single generation can watch the whole transition from start to finish. What makes the African Humid Period so compelling is that it sits close enough to us in time to feel almost familiar. We are not speaking here about a lost tropical world from the age of dinosaurs or some vanished coastline from a period so remote it barely registers as humanly meaningful. This greener Sahara existed during the Holocene, the geological epoch we are still living in now. In other words, this was not another planet's version of North Africa. This was our planet, in broadly the same arrangement of continents and coastlines we know today, inhabited by humans recognisably like us, under a sky not all that different from the one above us now, and yet the environmental reality of the region was transformed. That idea can be strangely grounding. It means the world we know is not the only version of itself that has ever existed. Beneath what seems ordinary lies a history of reversals and surprises. The dry basin may once have been a lake, the grassland may once have been scrub, the forest may once have been open plain, and all of those states may leave clues behind if one knows how to read them. A shell in the wrong place, fossil pollen buried in layers of mud, the bones of fish where now there is no permanent water, rock art showing animals that could not live there today, ancient shorelines visible from the air like faint signatures of a forgotten geography. The Sahara, despite its reputation for emptiness, is full of evidence. One only has to stop expecting the present to explain the past. There is also something quietly humbling about the way we talk about deserts. We tend to speak of them as final forms, as though once a land becomes dry enough, it has reached some kind of endpoint. Perhaps that is because deserts look minimal, and humans are often tempted to treat minimal things as last versions. But deserts too have histories. They expand and contract. They pulse over long intervals. They respond to planetary rhythms far larger than any one season or century. The Sahara of today is real, powerful and ecologically important in its own right, but it is not the only Sahara that has existed. There have been greener Saharas before, and the famous humid period we're exploring tonight was one of the most dramatic examples. Imagine for a moment someone standing in what is now a remote stretch of Saharan desert thousands of years ago. The air would not have been the same. The ground beneath their feet might have been soft with vegetation in places or damp near the margins of a lake. There may have been reeds whispering in the shallows, fish moving in the water, birds lifting from wetlands, and herds grazing across nearby grasslands. The soundscape alone would have been transformed. Modern deserts can be astonishingly quiet, especially at night, but a wetter Sahara would have carried the sounds of insects, frogs, splashing animals, wind moving through leaves and grasses, human activity along shorelines, perhaps even the low constant murmur of water not far away. It is difficult, standing in today's Sahara, to reconstruct that world emotionally as well as intellectually. And yet that difficulty is part of the fascination. The contrast is so sharp that it forces the mind to stretch. Of course, when people first hear that the Sahara was once green, they often picture a single giant meadow laid neatly across all of North Africa, as if someone had rolled out a carpet of grass from the Atlantic to the Nile and called it a day. The real story is more interesting than that, and more textured. No enormous region is ever just one thing. Even during wetter phases, the Sahara was not a uniform paradise of equal rainfall and identical ecology. There would have been lakes here, rivers there, broad grasslands in many places, patchier cover in others, zones of scrub, seasonal wetlands, corridors especially rich in life, and areas still comparatively dry. Climate change does not paint with a single brush. It creates mosaics. Some places become lush sooner, some hold on to water longer, some serve as passageways for animals and people, some become refuges. A greener Sahara was not simply a desert switched off. It was a living, shifting landscape with gradients, seasons, and local differences. That matters because it keeps us from turning the past into fantasy. The African Humid Period was not a fairy tale interval in which every hardship disappeared and the continent suddenly transformed into one endless Eden. People still had to move, adapt, cooperate, and respond to changes in weather and water availability. Animals still followed grazing opportunities. Lakes rose and fell. Seasons mattered. But compared with the immense aridity that defines much of the Sahara today, the difference was extraordinary. It opened vast territories that are now forbidding. It allowed life to spread through regions that would later become barriers. It changed migration routes, ecological communities, and the possibilities available to human societies. There is another reason this story matters, and it is not only because it is surprising. It matters because it reveals how sensitive large systems can be to shifts in climate patterns. We're often taught climate in local terms. Is it warm this week? Cold this winter? Wet this year? But the African Humid Period reminds us that climate can reorganize entire regions for millennia. When the rains move, civilizations, ecosystems, and migration routes move with them. The boundary between habitable and difficult land is not always where it is now. And if that sounds relevant beyond prehistory, well, it is hard not to notice the echo. The Earth has always been dynamic. The comfort and discomfort of that fact depend largely on whether one is reading about it from a sofa or living through it in real time. Still, there is no need to rush ahead. Before we ask why the Sahara grew green, before we deal with orbital cycles, monsoon systems, and the great machinery of climate, it helps to sit with the basic wonder of the idea itself. A desert so large that it seems to define dryness for an entire hemisphere was, within the span of human prehistory, hospitable in a way that now feels almost counterintuitive. And people did not merely pass through it like nervous guests at an unfamiliar gathering. They lived there. They made use of lakes and rivers. They adapted to the opportunities the land offered. They left traces that would wait, sometimes for thousands of years, under sand and stone until archaeologists, geologists, paleoclimatologists, and patient local knowledge began piecing the picture together. One of the loveliest things about this sort of science is that no single clue is enough on its own. A dried lake bed does not tell the whole story. Neither does a carved rock face, nor a set of animal bones, nor a layer of pollen buried in sediment. But gradually evidence begins to converge. A former shoreline here, fresh water shells there, fish remains in places now almost unimaginably dry, rock art depicting giraffes, cattle, swimmers, crocodiles, and scenes of life that simply do not belong to the modern desert. Each clue is modest. Together they are impossible to ignore. The land begins to testify against our assumptions. It says, gently but firmly, you have mistaken the current scene for the whole play. And perhaps that is part of why this topic settles so well into the kind of conversation we have here. It is scientific, certainly, but it is also corrective in a very human way. It reminds us to be careful with words like always and never. The desert was not always this dry. The emptiness was not always so empty. The line between abundance and scarcity has moved before. Under the surface of modern landscapes lie older versions waiting to be remembered. And once you begin to see that, it changes the way you look at almost every place on Earth. Coastlines become temporary, forests become historical, rivers become negotiators between climate and stone. Even the ground beneath your own feet begins to feel a little less settled in identity, and a little more like the latest draft in a very long revision. There is also something deeply compelling about the human angle. It is one thing to say the Sahara had lakes. It is another to picture people waking beside them. Children learning the edges of shorelines. Fish being caught in waters now gone. Camps established where dunes would later rise. Movement across a landscape that to them was not a dead zone but a lived world, with familiar routes, resources, dangers and comforts. We tend to separate nature and human history too neatly, as though one is a backdrop and the other the main event. But in a story like this that division falls apart, climate shaped the possibilities, water created pathways, plants and animals established communities. Humans entered that web not as distant observers but as participants. And once you start thinking that way, the modern desert acquires a strange kind of depth. Those dunes are not merely dunes. In some places they cover lake sediments, old soils, former campsites, tool scatters, rock surfaces marked by people who looked out on a very different horizon. The desert becomes layered rather than empty. Severe on the surface, yes, but crowded with memory underneath. There is something almost theatrical about that. Sand, for all its openness, is also very good at covering things up. It preserves, conceals, erases, reveals, and rearranges. A place can look blank and still contain a library of environmental history below ground. If you listen closely, that is what the Green Sahara story really is at the beginning. An exercise in learning how to hear a landscape disagree with its own appearance. The present says desert. The buried evidence says not so fast. The rocks, the sediments, the fossil traces, the art, the remnants of shorelines and ancient ecologies all speak in low voices, but they speak consistently. They tell us that North Africa has not simply endured one climatic identity through the ages, it has swung between states. And during one especially important interval, life spread across much of the region, in ways that feel startling only because we arrived late to the scene and assumed the set had never been changed. So as we ease further into this story, it helps to hold two images in the mind at once. The first is the Sahara we know now. Dry, immense, difficult, beautiful in a stark and exacting way. The second is the Sahara that existed during the African Humid Period. Wetter, greener, more inhabited by rivers, lakes, grasslands, animals and people than our instincts might allow at first glance. The distance between those two images is where the real fascination lies. Not in choosing one over the other, but in understanding how one became the other, and how the Earth can move a region from one state to the next, with such profound consequences for everything that lives there. Because once that possibility opens, the next question arrives almost by itself. What, exactly, did this greener Sahara look like on the ground? Not in broad slogans or tidy textbook summaries, but as a real landscape of water, vegetation, movement, and daily life. To answer that, we have to step out of the abstract and begin picturing the lakes, rivers, wetlands, and living corridors that turned so much of the desert into something very different from the world we know today. Long before the Sahara became the vast dry expanse we know today, large parts of it were shaped by water. Not a puddle here and there after a rare storm, not the brief and reluctant kind of rainfall that vanishes before the ground has fully decided what to do with it, but sustained water, enough to build landscapes around. There were lakes broad enough to hold fish and crocodiles, rivers that cut channels across ground now buried under sand and gravel, wetlands thick with reeds, and grasslands that depended on regular seasonal rain. If you had stood in many parts of the Sahara during the African Humid Period, you would not have thought of it as a desert interrupted by a few lucky pools. You would have seen a living region with water at its centre, a place where the sky and the land were in much closer agreement than they are now. That can be hard to picture, because the modern Sahara is so visually persuasive. It does not merely look dry, it looks committed to the idea. The dunes, The bare rock, the salt flats, the immense open distances, they all suggest permanence. But the ground tells another story if you know where to look. Ancient shorelines remain etched into places that now sit far from any permanent lake. Sediments at the bottom of dry basins preserve evidence of freshwater life. Fossil pollen reveals plants that could only have grown with much more reliable moisture. Old river channels, some visible from satellite imagery, run across terrain now too dry to support anything like them. In some places, the land has the awkward dignity of someone trying to pretend nothing happened, while still wearing obvious evidence of the event on their sleeve. One of the first things to understand is that the greener Sahara was not simply one giant lake with a few bits of land sticking out. It was a networked landscape. There were massive lakes in some basins, smaller lakes and ponds in others, seasonal wetlands, river systems, floodplains, marshy depressions, and stretches of open country that benefited from much higher rainfall than today. Water moved through the region in different ways depending on topography, local climate, and seasonal patterns. Some basins filled and held water for long periods. Some swelled during wetter seasons and contracted during drier ones. Rivers connected certain areas, turning what are now barriers into corridors. In ecological terms, this changed everything. Water creates edges, and edges are busy places. Shorelines attract plants, birds, fish, grazing animals, predators, and of course people. Because where water settles, life starts making plans. A particularly striking example comes from the huge paleolakes that once occupied parts of the Sahara. Lake Chad, which still exists today in reduced and fluctuating form, gives us a hint of what a larger wetter system can mean for this region. During the African Humid Period, what researchers often call Mega Lake Chad expanded to a scale that is difficult to grasp if one only knows its present condition. At its peak, it covered an enormous area, far larger than the lake of today, creating an inland water body that reshaped the surrounding environment. It supported fish populations, attracted animals from surrounding grasslands, and influenced local climate conditions. A lake of that size is not just a passive container of water, it becomes part of the regional system. It stores heat, affects humidity, alters vegetation patterns nearby, and anchors human and animal movement in ways that smaller, temporary water sources simply cannot. And Mega Lake Chad was not alone. Across the Sahara, there were other basins that filled during humid intervals. In Libya, Egypt, Sudan, Niger, Mali, Algeria, and elsewhere, evidence points to lakes that occupied depressions now dry or reduced beyond recognition. Some of these lakes lasted for long spans of time, others fluctuated, rising and falling as rainfall patterns shifted. The important point is that this was not an isolated local oddity. It was a widespread hydrological transformation across much of North Africa. Regions that now receive almost no dependable rainfall once had enough moisture to sustain standing water at scales that left lasting marks in the land. Rivers too played a major role. Today many Saharan river valleys are dry for most or all of the year, and some are difficult to recognise unless you know how river systems leave signatures in terrain. But during wetter periods, runoff from seasonal rains and more persistent precipitation fed channels that carried water across broad areas. Some river systems were linked to higher terrain, such as mountain massifs, where rainfall could collect and flow outward. Others formed as drainage networks in response to more extensive monsoonal rains. Ancient river courses identified through remote sensing and geological work suggest that water once moved across parts of the Sahara in organised patterns, not just in short-lived flash floods. In some cases, these channels may have connected interior basins, creating aquatic pathways or chains of habitable zones. A fish, admittedly, is not in the habit of publishing a travel diary, but the distribution of freshwater species helps make the point that these waters were not merely decorative. There is a tendency, when hearing about prehistoric rivers in the Sahara, to imagine something modest, like a trickle bravely crossing a hot plain before giving up by lunchtime. But in several areas the evidence suggests much more substantial and ecologically meaningful flow. Channel forms, sediment deposits, and associated biological remains indicate that some of these systems were active enough to support long-lived environments along their courses. Riverbanks are naturally rich places. They gather nutrients, support denser vegetation, and provide predictable access to water compared with open grassland farther away. For animals, they become routes of movement. For humans, they become places worth revisiting. One can camp beside a river with far more confidence than beside a hopeful patch of damp ground and a good attitude. Then there were the wetlands, which are easy to underestimate because they do not always command the same imagination as lakes and rivers. Yet wetlands are often among the most productive environments in any landscape. Marshes, floodplains, shallow vegetated basins, and seasonally inundated areas create ideal conditions for birds, amphibians, fish nurseries, aquatic plants, insects, and grazing animals that feed on lush nearby growth. In a greener Sahara, these wet areas would have added complexity and resilience to the broader ecosystem. A place did not need to be deep open water to be important. In fact, some of the most biologically rich zones were probably the shallow margins where land and water blurred into each other. The kind of places where reeds grow thick, footprints accumulate, and mosquitoes become insufferably pleased with themselves. Rainfall, of course, sits behind all of this. Lakes do not fill themselves out of optimism, and rivers are not moved by scenery alone. The African Humid Period was humid because rainfall increased dramatically over much of North Africa. Seasonal rains associated with the African monsoon pushed much farther north than they do today, bringing moisture into areas that are now dry for most of the year. That northward reach mattered enormously. Modern climate patterns place much of the Sahara beyond the reliable influence of the monsoon, leaving it under descending dry air that suppresses rainfall. During the humid period, that balance shifted. The summer rains moved deeper into the continent's interior and farther north across the desert zone, supporting plant growth and surface water over large areas. This did not mean constant rain, as though the prehistoric Sahara had become a place of daily drizzle and people spent their afternoons complaining about damp laundry. The climate would still have been seasonal, with wet and dry periods, and rainfall likely varied from region to region. But there was enough regular moisture to sustain vegetation and hydrology at a completely different level from the present. Seasonality can still produce very productive landscapes when the wet phase is strong enough. In fact, strongly seasonal systems often create pulses of abundance that shape migration, breeding, and human subsistence in very clear ways. If the rains come dependably enough, plants grow, herbivores follow, predators follow them, and people quickly learn when and where the landscape is most generous. Once vegetation expanded, it also helped reinforce the wet conditions. This is one of the most interesting parts of the story, because landscapes do not only respond to climate, they can feed back into it. Bare desert surfaces reflect sunlight differently from vegetated land, and they interact with the atmosphere in different ways. When plants spread, they alter surface albedo, moisture recycling, and the exchange of heat between land and air. More vegetation can help sustain conditions that support further rainfall, at least up to a point. In other words, once the Sahara began greening, it may have become easier for that greener state to persist for a long time. Earth systems are often like that. They are not content with simple cause and effect. They prefer loops, reinforcements, thresholds, and the occasional dramatic reversal. What would the region have looked like on the ground? Not uniform, certainly, but in many areas more like savanna, steppe, or mosaic grassland than desert. Around lakes and rivers there would have been denser vegetation, including reeds, sedges, and shrubs. In areas with sufficient rainfall, grasses would have spread widely. Trees were present in some zones as well, especially in regions receiving more moisture or benefiting from local hydrology. This was not a closed tropical forest stretching wall to wall across North Africa, but it was a much greener and more structured landscape than today's open desert. The presence of grazing animals, freshwater species and plant remains supports a picture of ecological diversity rather than a single monotonous environment. That diversity mattered for human life. A land of lakes, rivers and rain is not just easier to cross. It invites settlement, movement, innovation and repeated use. Water sources provide fish, attract game, support edible plants, and create reliable staging points from which people can range outward. In a hyper-arid desert, human mobility is constrained by survival. In a wetter landscape, mobility becomes strategic rather than desperate. You move because certain places are good at certain times, because the fish are running, because grazing is better in one basin this season than another, because resources are distributed across a landscape that is alive rather than largely closed to you. A greener Sahara would not have erased risk or hardship, but it would have opened choices, and choices are what let cultures and lifeways develop in more varied ways. Evidence for this older, watery world comes from many different directions, and that is part of why the case is so strong. Sediment cores from former lake beds preserve layers of mud laid down in standing water. Those layers can contain diatoms, microscopic algae with silica shells, which are excellent witnesses if one is patient enough to interview them under a microscope. Pollen grains trapped in sediments reveal what kinds of plants grew nearby. Freshwater mollusk shells indicate that lakes and wetlands were not just temporary puddles. Fish bones, crocodile remains, and hippo bones found in now arid areas tell a direct and rather persuasive story. Rock art depicting swimmers, cattle, giraffes, crocodiles, and scenes of daily life adds cultural testimony to the environmental record. One does have to interpret art carefully, as humans have always been capable of exaggeration, omission, and personal flair. But when the art aligns with geological and biological evidence, the picture becomes difficult to dispute. Satellite imagery has added another layer of clarity. From above, the Sahara reveals hidden drainage patterns, buried channels, ancient deltas, and the outlines of former lakes more clearly than one can often see from the ground. What seems random and barren at eye level can resolve into unmistakable structure from space. There is something slightly amusing about needing satellites to appreciate the watery past of a desert, but science is like that. Sometimes the grandest ancient river leaves a clearer mark when viewed by machines orbiting far above than by a person standing directly on its old bed wondering why the gravel looks oddly arranged. The sheer timescale of these hydrological changes is also worth sitting with for a moment. The African Humid Period did not begin and end in a single dramatic year. As though North Africa received an especially enthusiastic rainy season and decided to reinvent itself. It unfolded over thousands of years, with wetter conditions developing, stabilizing, fluctuating, and eventually declining. That length of time matters because ecosystems respond differently to centuries and millennia than to short-lived anomalies. Plants spread gradually, soils develop, animal populations expand and establish patterns. Human communities adapt their strategies to landscapes that feel normal within the span of their own lives, even if those landscapes are temporary in geological terms. For someone living beside a Saharan lake 5,000 or 6,000 years ago, that lake was not a curious climate episode. It was simply part of the world. There is also an important point about memory and inheritance here. Landscapes teach behaviour. If people live for generations in a region of water and grassland, their roots, skills, technologies and expectations reflect that world. A child raised near a lake learns a different environment from one raised in a dune field. Fishing gear, seasonal mobility, knowledge of reed beds, bird migrations, flood timing, edible aquatic plants, and the habits of grazing animals all become culturally meaningful when water is abundant. The later drying of the Sahara would not merely have removed resources, it would have disrupted long-established ways of knowing and using the land. But at this stage in the story, the wetter landscape is still in place, and it helps to remember that it was not a brief surprise to those living within it. It was home. The atmosphere of such a Sahara would have been different in ways beyond rainfall totals. More surface water and vegetation can mean cooler local temperatures in some areas, more humidity, more cloud formation, and less dust than in today's hyper-arid conditions. Dust is a major feature of the modern Sahara, and vast plumes from the desert travel across oceans, affecting weather, soils, and marine systems far away. A greener Sahara would have produced less dust in many areas because the ground was held in place by plants and moisture. The air itself would have felt different, and visibility in some seasons may have reflected a less dust-loaded environment. The modern Sahara is a place where the atmosphere and the land often seem to work together in the business of desiccation. During the humid period, that partnership was much less severe. One can also think of the old Sahara as a connective space rather than a dividing one. Today the desert is often treated as a formidable barrier between regions to its north and south. In wetter times, that barrier weakened. Corridors of water and grassland made movement more feasible for animals and humans alike. Species distribution shifted. Genetic exchange became easier across areas that would later be much harder to cross. This is one reason the Green Sahara matters so much beyond North Africa itself. It was not just an environmental curiosity. It was a continental reorganization of habitable space. It changed what could move where, and when that happens for long enough, it influences everything from ecology to human history. And still, even with all this water, it would have remained a dynamic place. Lakes rose and fell. Rivers changed course. Local droughts likely occurred within the broader humid framework. Some basins may have dried seasonally, while others remained stable. The picture is one of abundance relative to today, not perfect uniform reliability. In fact, part of what makes these landscapes productive is their variation. Shorelines expand and contract, exposing fresh feeding grounds for birds and grazing animals. Floodplains replenish nutrients. Seasonal differences create rhythms that both wildlife and human societies can track. Stability in the broad sense does not mean sameness in every month. Perhaps the most useful correction to carry forward is this. The Sahara before sand was not empty land waiting to become dramatic. It was already dramatic, just in a different register. Its drama came from rainfall arriving where it does not now, from lakes stretching across basins that today lie silent, from river systems threading through ground that would later harden and dry, from animals grazing and drinking in places now famous for their hostility to life. The modern desert is impressive partly because it looks like an ultimate state. The greener Sahara is impressive because it reminds us there is no such thing. Landscapes keep negotiating with climate, and sometimes the results are so different from the present that they seem almost implausible until the evidence piles high enough to make disbelief look lazy. So when we picture the Sahara during the African Humid Period, it helps not to imagine a miracle and not to imagine a fantasy. Better to picture a real North African landscape under a different climatic arrangement, one in which monsoon rains reached farther north, water gathered in basins and channels, plants spread across wide areas, and entire ecological communities formed around that abundance. It was a land of lakes, rivers, and rain, not because the desert briefly forgot itself, but because the atmospheric rules had changed, and the land responded exactly as living landscapes do when water returns in earnest. Which leads to the next question quite naturally, because once we accept that the Sahara was greener, we have to ask what shifted in the sky and on the earth itself to send the rains so far north in the first place. If the Sahara became green, then the obvious question is what changed in the sky to make that possible? Lakes do not appear because a landscape suddenly develops optimism. Rivers do not flow because the ground has had a change of heart. Somewhere above all that sediment, grass and shoreline, the atmosphere had to behave differently for a very long time, and it did. The African Humid Period was not a local accident or a lucky sequence of rainy years. It was the result of a large climatic shift that altered where the summer monsoon reached, how much moisture it carried, and how the land itself responded once the rains began to arrive farther north. To understand that, it helps to begin with the monsoon itself, because the word is often treated as if it simply means a dramatic downpour and a person sprinting towards shelter while pretending not to panic about the laundry. But a monsoon is really a seasonal wind and rainfall system, driven by differences in heating between land and ocean. In summer, land heats up faster than the sea. Warm air over land rises, creating lower pressure, and that helps pull in moist air from over the ocean. When conditions are right, that moisture-laden air moves inland, rises, cools, and drops rain. The stronger the contrast in heating, and the more favourable the circulation, the farther inland that rainy system can push. In Africa today, the summer monsoon brings rain to parts of West and Central Africa, nourishing the Sahel and regions farther south. But most of the Sahara sits beyond the reliable reach of that moisture. The rains weaken before they get far enough north to transform the desert on a large scale. During the African Humid Period, that pattern changed. The summer monsoon shifted northward, carrying rain deep into areas that are now dry. This was not because the Atlantic suddenly decided to become unusually generous out of good manners. It was tied to changes in the amount of solar energy received in the Northern Hemisphere during summer, and those changes were linked to slow variations in Earth's orbit and axial orientation. This is where climate science becomes both grand and slightly humbling, because it turns out that the fate of lakes in the Sahara can be connected to celestial mechanics. One might think the daily weather forecast is already trying hard enough without the Earth's wobble getting involved, but here we are. Earth does not move around the sun in a perfectly unchanging way. Over long timescales, there are predictable variations in its orbit, tilt, and the timing of the seasons relative to its position around the sun. These are often grouped under the name Milankovitch cycles, and they influence how solar radiation is distributed across the planet. One of the most important for the African Humid Period is precession, the slow wobble of Earth's axis. Precession affects when the seasons occur relative to Earth's closest and farthest points from the sun. At certain times, Northern Hemisphere summer occurs when Earth is positioned so that summers there receive more solar energy than usual. When that happens, land surfaces in North Africa heat more strongly during summer. That extra summer heating matters a great deal. Hotter land intensifies the land-sea thermal contrast, which strengthens the monsoon circulation. Stronger rising air over the continent helps draw moist air farther inland from the tropical Atlantic and adjacent oceanic regions. The rain belt shifts north. Areas that today sit outside the main zone of reliable monsoonal rainfall begin to receive enough summer precipitation to support grasslands, lakes, wetlands, and the expansion of plant cover. In other words, the climate system redraws the map of where water is likely to be found. And once you redraw the water map, nearly everything else starts reorganizing itself. This was not a matter of the rains nudging north by a polite distance and then stopping for tea. The shift was substantial. Large parts of what is now the Sahara experienced rainfall levels much higher than they do today. Different regions would have seen different amounts, of course, and the landscape remained varied, but the overall result was a greener, wetter North Africa, extending far beyond the modern monsoon boundary. The modern Sahara is often seen as the stable default, and the humid phase as the anomaly. In one sense, that is understandable, because we are alive now and the desert is what we see. But from the point of view of the climate system, both states are part of a longer pattern of swings between wetter and drier conditions. The humid phase was not a glitch. It was a recurring possibility built into the planetary setup. Still, orbital forcing on its own does not tell the whole story, because climate systems are not simple machines where one knob turns and one neat result appears. If that were the case, climate scientists would sleep more peacefully and spend less time trying to explain feedbacks to the rest of us. The northward shift of the monsoon was initiated by stronger summer insolation in the northern hemisphere, but the persistence and scale of the African Humid Period were also shaped by feedback mechanisms that amplified the response. Once vegetation began to spread across formerly bare surfaces, it changed the properties of the land. Plants tend to darken the surface relative to bright desert sand, which means more solar energy is absorbed rather than reflected. Vegetation also affects evapotranspiration. the movement of water from soil and plants back into the atmosphere. That can increase local and regional moisture recycling. More plants can help sustain more rain, which supports more plants, at least within the bounds of the broader climate system. This is one reason the Sahara did not simply become a patchwork of isolated green spots, while remaining mostly unchanged elsewhere. Under the right conditions, vegetation-climate feedbacks can help stabilise a green estate over a large area. Think of it less like watering a few pots on a windowsill, and more like changing the operating mode of an entire landscape. Once plants spread, they modify temperature, surface roughness, moisture flux, and dust production. All of those can influence the atmosphere above. The Sahara is not merely a passive recipient of climate. It also helps shape regional atmospheric behaviour. That relationship is especially important when the land is on the edge between very different environmental states. Dust is another part of this story, and an important one. The modern Sahara is one of the planet's great dust sources. Dry, sparsely vegetated ground allows winds to lift enormous quantities of fine particles into the atmosphere. During the African Humid Period, increased vegetation and soil moisture reduce dust emissions in many areas. Less atmospheric dust can affect radiation and cloud processes, which in turn can influence climate. A greener Sahara was not just wetter on the ground. It likely looked different from above and behaved differently in the atmosphere. The reduction in dust was part of the broader shift from a dry, highly reflective dust-producing surface to a more vegetated and moisture-cycling one. Ocean conditions may also have played supporting roles, though the broad driver remains the orbital setup. Sea surface temperatures influence how much moisture is available and how atmospheric circulation develops. Warmer tropical waters can support stronger evaporation and help feed monsoonal systems. The exact interactions are complex, and different studies emphasize different combinations of factors, but the general point is clear enough. The monsoon moved north not because of a single isolated cause, but because orbital forcing pushed the system in that direction, and land-atmosphere feedbacks helped magnify and maintain the result. What is remarkable is how thoroughly this climatic shift rewrote the geography of opportunity across North Africa. Climate is often described in terms of averages, but averages only matter because they control practical things. If summer rains move north, seeds germinate where they previously failed. Seasonal ponds persist long enough for breeding cycles. Grasses spread into areas that were once mostly bare. Herbivores can occupy new grazing grounds. Predators follow them. Human communities can travel routes that would otherwise be impossible or highly risky. A line on a climate map becomes a chain of lakes, then a feeding ground, then a migration corridor, then a lived landscape. That is how continents get rewritten. Not by abstract figures alone, but by those figures becoming water, and those waters becoming life. The African monsoon today already shows how powerful seasonal rain can be in shaping a region. The Sahel, lying south of the Sahara, is strongly influenced by year-to-year and decade-to-decade shifts in rainfall. A modest change in monsoon strength can mean major consequences for vegetation, agriculture, pastoral movement, and water availability. Now imagine that same system shifted much farther north and sustained over millennia rather than seasons or decades. That is the scale of transformation we are dealing with. The African Humid Period was not simply a greener version of the modern Sahel. It was the expansion of monsoonal influence into what is now core desert. There is also a timing issue worth understanding. The African Humid Period did not begin the instant summer insolation increased, nor did it end like a switch being flipped one Tuesday afternoon while everyone was out minding their wetlands. Climate systems have inertia, ice sheets, ocean circulation, vegetation cover, and soil development all affect how quickly a region responds. In general, the humid period developed during the early to middle Holocene, after the end of the last ice age, when orbital conditions favoured stronger northern hemisphere summer heating. Over time, as precession continued to shift and summer insolation declined, the monsoon weakened and retreated southward. But the decline was not uniform everywhere, and different parts of the Sahara dried at different rates. Some areas may have crossed ecological thresholds abruptly, while others experienced a more gradual transition. That variation is important because real landscapes rarely obey tidy timelines. The idea of thresholds matters here. A system can absorb change for a while and still look broadly similar, then suddenly reorganize once a tipping point is reached. If rainfall drops below what certain plant communities need, vegetation cover can shrink rapidly. Less vegetation means more exposed ground, more dust, more reflected sunlight, and weaker moisture recycling, which can in turn make it even harder for the old wet regime to persist. A greener Sahara may have remained fairly stable under one set of conditions, then unravelled relatively quickly once those conditions crossed critical limits. This is one reason the end of the humid period is such a compelling topic. But for now, the key thing is that the expansion northward was not only a matter of stronger rains arriving, it was also a matter of the land becoming increasingly able to sustain the consequences of those rains. There is a tendency when discussing climate shifts in prehistory to imagine them as remote and impersonal, the sort of thing represented by a coloured band on a graph that politely declines to affect one's afternoon. But these changes were intensely physical. They shaped what the sky looked like in summer. They determined where clouds built up, where storms travelled, where grasses rose after rain, where lakes filled, and where the ground stayed damp long enough to support reeds, fish, and grazing herds. For people living through it, this was not orbital precession. It was the normal pattern of seasons. The rains came, water collected, the land fed animals, paths existed where they might not later exist. These are always worth remembering. Climate mechanisms are scientific explanations, but they are explaining lived worlds. The phrase, "how climate rewrote a continent," can sound a bit dramatic until you pause and realise that it is almost understated. Climate did not simply make the Sahara prettier for a while, it changed hydrology, vegetation, animal ranges, human mobility, and the relationship between regions north and south of the desert. It altered what kinds of ecological communities could exist over huge distances. North Africa, under a stronger monsoon, was not just a wetter place. It was structured differently. Connections opened that were later severed. Habitats expanded and contracted. Resources appeared where there had been little before. A child born into the greener Sahara would inherit a different map of the possible than one born into the desert that followed. There is something slightly mischievous about the role of the sun in all this. We are used to thinking of the sun as constant in practical terms. It rises, it warms, it makes the pavement too hot if you are reckless enough to touch it in summer, and that is the end of the matter. But when climate scientists discuss long-term environmental change, they often have to remind us that what matters is not only the total sunlight reaching Earth, but when and where that energy is concentrated. A stronger northern hemisphere summer does not mean the entire planet suddenly becomes uniformly hotter in every sense. It means seasonal heating patterns shift, and those shifts can strongly alter atmospheric circulation. The African monsoon is one of the systems especially sensitive to that. A few changes in the geometry of Earth's movement relative to the sun, spread over thousands of years, and suddenly the rain belt is spending much more time visiting places it now mostly ignores. None of this means the Sahara became tropical rainforest, and it is important not to overcorrect. The northward monsoon created a greener Sahara, but within a spectrum of environments. Some zones likely resembled open savanna with seasonal grasses and scattered trees. Others supported lakes and wetlands with rich aquatic life. Some remained drier or more patchy, especially toward the margins or in areas with less favourable local conditions. Yet even with that variation, the overall transformation was profound. The continent's climate zones had shifted enough that North Africa supported ecosystems far more extensive and connected than today's arid map would suggest. Climate models have been especially useful in helping researchers test how these changes might have worked. When scientists adjust orbital parameters to simulate early Holocene conditions, models tend to show stronger summer heating over North Africa and a northward expansion of monsoonal rainfall. However, early modelling efforts often underestimated how green and wet the Sahara became compared with what the geological evidence indicates. That mismatch itself taught researchers something important. It suggested that feedbacks involving vegetation, dust and land surface changes were crucial. Add those processes more fully, and the models come closer to the environmental record. It is a nice reminder that Earth systems are rarely impressed by our first simplified attempt to describe them. This matters beyond ancient North Africa, because it shows how sensitive monsoon systems can be to forcing and feedbacks. Monsoons are not just rain machines. They are large atmospheric engines connected to land temperature, ocean conditions, vegetation aerosols, and seasonal energy gradients. Change one part enough, and the effects can propagate across huge regions. The African Humid Period is one of the clearest examples of this sensitivity preserved in the Holocene record. It demonstrates that the boundary between green land and desert is not simply a line waiting to be drawn once. It can move dramatically when the climate system is pushed into a different state. There is also an emotional challenge in thinking about continental climate change. A human mind likes stable categories: desert, grassland, wetland, forest. It likes names that behave themselves, but the real Earth is less disciplined. Over long timescales, deserts can become grasslands, and grasslands can fail. Lakes appear and vanish. Rivers migrate. Climate rewrites the same terrain more than once, and each version feels permanent to those living inside it. That may be one reason the Green Sahara story lands so strongly. It disrupts a category that seems immovable. It tells us that one of the most iconic deserts on Earth was, not terribly long ago in geological terms, under the influence of summer rains that turned much of it into something else. And once the rains moved north, the land did what land nearly always does when water arrives with enough consistency. It grew things. That may sound obvious, but it is really the hinge on which the whole story turns. Rainfall is the invitation. Vegetation is the response. The monsoon could only rewrite the continent because plants followed the moisture and began transforming the surface. Grasses spread, shrubs and trees established themselves where conditions allowed, wetlands thickened, and what had been bare or sparsely covered ground became habitat. Without that greening, the hydrological shift would still have mattered, but it would not have built the same living world. Once we follow the water to its next consequence, we arrive at the landscape itself, covered not in dunes and open gravel, but in plant communities that gave the greener Sahara its structure, its food webs, and its surprisingly full sense of life. When people hear that the Sahara was once green, they often imagine a simple before and after scene, as though someone took the modern desert, added rain, and watched grass appear like a fast-motion gardening video. But the plant world of the Green Sahara was more interesting than that, and much more layered. It was not just a desert with better manners. It was a varied living landscape made up of grasses, shrubs, trees, wetland plants, and river-edge vegetation, all arranged according to water, soil, season, and local topography. In many places, the dominant impression would likely have been open grassland or steppe, with scattered woody cover rather than a closed forest. Pollen evidence suggests the Sahara during the humid phase remained strongly grass-dominated overall, even while it also hosted tropical and Sahelian tree species that are now found hundreds of kilometres farther south. That point is worth lingering on, because it helps prevent the most common misunderstanding. A greener Sahara was not a giant rainforest misplaced by geography. It was, in broad terms, a mosaic of open herbaceous landscapes, wooded grasslands, shrublands, wetlands, and gallery forests along rivers and lakes. Some researchers have suggested that during the mid-Holocene the boundary between steppes and wooded grasslands lay around 20 degrees north in the Western Sahara and around 25 degrees north in the Eastern Sahara, with steppe vegetation extending widely as far as 30 degrees north. That means the plant cover reached impressively far into what is now deep desert, but it did so in forms suited to seasonal rainfall, not by turning the region into a wall-to-wall canopy of dense trees. Grasses were the backbone of this world. They formed the broad green surface on which much of the rest of the ecosystem depended. If you had looked across many parts of the humid period Sahara after the rains, you likely would have seen expanses of herbaceous cover, moving in the wind, supporting grazers, protecting soil and changing the surface of the land in practical ways. Grasses matter not only because they are visually transformative, but because they anchor an entire ecological system. They slow erosion, trap moisture, create fuel for fire, support insects, and feed herbivores from antelope to larger mammals. The Sahara's greener phase was therefore not just a story of plants decorating the scenery. The vegetation was the scenery, and more importantly, it was the structure that made the rest of the living system possible. Studies of Holocene vegetation change across North Africa consistently describe a mesic, more vegetated Sahara in place of today's hyper-arid and semi-arid environment. Around lakes and marshes, the vegetation would have changed again. Wetland edges support plants that open dry country cannot. Reeds, sedges, and aquatic or semi-aquatic plants would have occupied shallow margins and damp depressions, creating zones of thick cover around standing water. These are not glamorous plants in the way a giant tree is glamorous, but ecologically they are extremely important. They provide habitat for fish nurseries, insects, amphibians and birds. They stabilise muddy shorelines. They filter sediment. They also create the sort of places where people can gather plant materials for mats, baskets, shelters, cordage, and all the useful things human societies tend to invent very quickly once they discover that reeds are nature's version of a building supply aisle. The expansion of lakes and wetlands across the Sahara at the height of the African Humid Period is one of the clearest signals that this kind of moisture-dependent vegetation must have been widespread in many basins. Then there were the woody plants of the Sahelian and Saharo-Sahelian worlds, which seem to have moved north into the Sahara as rainfall increased. Pollen data indicate that plant types associated with modern Sahelian and Sahelo-Saharan wooded grasslands, including acacia, commiphora, balanites, salvadora, and Boschia cadaba, expanded widely during the Holocene humid phase, with some records reaching up to about 25 degrees north in southern Libya. Acacia in particular achieved notable abundance in some records, while salvadora and balanites also spread substantially. This is a very helpful clue, because these are the kinds of plants that fit a seasonal, semi-open, water-limited but still productive environment. They suggest not a fantasy landscape but a credible one. Broad grasslands with shrubs and scattered trees, more generous than today, but still recognisably African dryland vegetation in many places. Acacia deserves a brief pause, because it is the sort of tree that quietly explains a lot about dryland ecology. It is tough, useful, and not given to dramatics. In environments with seasonal rainfall, acacia species can survive heat, support browsing animals, enrich soils through nitrogen fixation in some cases, and create patches of shade and shelter out of all proportion to their size. A few trees in an open landscape can change where animals rest, where birds perch, where dung accumulates, where seeds gather, and where people choose to stop. One does not need a forest to make a landscape biologically busy. A grassland with scattered woody plants is already full of gradients, and gradients are where ecology gets interesting. The northward spread of woody grassland taxa during the Green Sahara tells us that much of the region was not just damp enough to sprout annual growth, but stable enough in some areas to sustain established shrub and tree communities. At the same time, the greener Sahara also included plants from more humid tropical regions. This is one of the most surprising and important parts of the record. Fossil pollen and botanical evidence show that a significant number of tropical tree species entered the Saharan region during the Holocene, some of them from areas now 400 to 500 kilometers farther south. Taxa such as Alcornia, Celtis type, Syzygium type, and Pileostigma moved northward into what is now desert, beginning roughly in the early Holocene and reaching various Saharan and Sahelian sites over time. Their movement did not happen as one tidy migrating forest block. Different taxa advanced at different rates, often on the order of a few hundred meters per year, which suggests individual plant responses rather than a single biome sliding north like a rug across a floor. That detail matters because it tells us the Green Sahara was not simply a shifted copy of the modern vegetation map. Researchers studying the pollen record explicitly argue that there is no evidence for one existing vegetation formation neatly replacing another. Instead, plant species typical of different ecological zones occupied a common space during the humid period. Humid adapted taxa from tropical forests and wooded grasslands overlapped with Saharan shrubs and dryland plants, creating what scientists describe as a no-analogue vegetation. In plain terms, the Sahara hosted plant communities that do not really exist anywhere today in quite the same combination. This is one of the reasons the region is so fascinating to paleoecologists. It was not just greener than now, it was organised differently from any modern North African landscape. Much of that overlap likely occurred along rivers, lakes, and low-lying freshwater settings. The tropical taxa do not appear to have formed dense continuous forests across the desert. Instead, the evidence suggests they often occupied gallery forests along rivers and around permanent or semi-permanent water bodies. That makes very good ecological sense. A gallery forest is a ribbon of trees following water through a more open landscape. It benefits from reliable moisture even when the surrounding region is more seasonal or drier. In the Green Sahara, reactivated paleo-drainages and the margins of lakes and depressions would have offered exactly the kind of refuge these plants needed. So you can picture much of the broader country as grassland or wooded steppe, cut through by greener, denser strips of riverbank vegetation, like natural corridors stitched across the land. Those gallery forests would have been disproportionately important. Rivers lined with Celtis-type, syzygium-type, or other water-favoured trees do more than add botanical variety. They create shade, microclimates, nesting sites, fruit resources, and protected movement corridors for animals and humans alike. They slow down the visual openness of the landscape. They turn a broad dry season plain into a place with shelter and reference points. If you are walking across open country, a riverine tree belt is not just a pleasant surprise. It is orientation, water, food, and perhaps the difference between continuing calmly and making poor decisions in the heat. One starts to see how a continental climate shift translates into ordinary practical consequences. A northward monsoon is one thing on paper. A ribbon of shade and fresh water where today there is only dry ground is quite another. It is also important to remember that dryland Saharan plants did not simply vanish because wetter conditions arrived. Species such as Ziziphus, Salvadora and Tamarix persisted alongside the more humid adapted arrivals. Other more arid associated taxa, including Ephedra and Caligonum in some settings, also remained part of the broader vegetation picture at different times and places. That persistence tells us two things. First, the Green Sahara still contained dry or seasonally stressed environments. Second, the ecological response to increased rainfall was not a simple erasure of the old desert flora, it was a mixing. The desert did not step off the stage entirely, it shared the stage with newcomers. That is precisely why the plant communities are so revealing. They record both the power of climatic change and the stubborn continuity of species already suited to the region. The balance between these plants would have varied from place to place. Near permanent water, more moisture-loving species could establish and persist. In open country with seasonal rain but less dependable surface water, grasses and dryland woody taxa would dominate. Around dunes and higher, better-drained ground, arid adapted species may have held their own quite effectively. This is the kind of detail that turns the Green Sahara from a slogan into a real landscape. Real landscapes are patchy. They have better bits and worse bits, favoured corridors and exposed stretches, places where growth is thick and places where it thins. The ancient Sahara was no different. It was greener, yes, but its greenness had geography. Fire probably played some role as well, especially in the more grass-rich parts of the system. Savanna and wooded grassland environments often involve fire as a recurring ecological force, shaping the balance between woody cover and open herbaceous growth. Research on West African Holocene ecosystems indicates that savanna expansion and diversification during wetter intervals could run alongside increased fire occurrence. That does not mean the Green Sahara was endlessly on fire like a badly supervised barbecue. It means that once grasses spread widely enough, fire became part of the ecological logic of the landscape, influencing which plants expanded, which retreated, and how open or wooded certain areas remained over time. The timing of these plant movements is also revealing. Tropical plant taxa began penetrating Sahelian and Saharan zones roughly from the early Holocene onward, with some reaching northern positions between about 12,500 and 9,000 years ago, depending on the species. Their advance was not simultaneous. Alchornea behaved differently from Syzygium, and Paleostigma had its own pattern again. Meanwhile, Sahelian woody taxa were also expanding northward, and the resulting vegetation was assembled gradually, species by species. This reminds us that even when climate shifts at regional scale, ecosystems do not move as a single obedient unit. Different plants have different dispersal abilities, different tolerances, different reproductive strategies, and different dependence on local hydrology. A changing climate does not move vegetation like a single object. It changes the odds for thousands of organisms one by one. That slower, piecemeal assembly is part of what would have made the Green Sahara feel so alive. Some places may have changed quickly after the rain strengthened, especially where seasonal grasses could establish on open ground. Other places would have taken longer as shrubs and trees spread, as soils changed and as wetlands developed. Over generations, people living in the region would have seen local landscapes mature. A depression that once held water only briefly might become a more reliable marsh. A river corridor might slowly gain more woody vegetation. Grazing grounds might improve, attracting more animals and altering seed dispersal in turn. The land would not have transformed in one cinematic sweep. It would have thickened, season by season, into a more complicated world. One of the most useful checks against exaggeration comes from the pollen itself. Even though tropical humid species are an important part of the story, they rarely exceed about 1% in many Saharan pollen sequences. The record remains heavily dominated by grasses. That means the dramatic element is not that the Sahara became a hidden rainforest, but that even a relatively low abundance of tropical taxa in a grass-dominated landscape reveals a huge geographic and climatic change. When a plant that now lives far to the south appears in sediments from the central Sahara, it is not the percentage alone that matters, it is the location. One Celtis pollen grain in the wrong place can ruin a tidy assumption very effectively. The visual result would probably have been a landscape far richer in texture than either the modern desert or a simple green plain image suggests. There would have been open grass country in many areas, especially after rains. Wetland belts around lakes with sedges and reeds, tree-lined channels and gallery forests following watercourses, thorny shrubs and hardy dryland trees scattered across slightly drier ground, perhaps denser woody patches in favoured localities. Dune fields may still have existed in places, but with different margins and more surrounding life. The phrase, "a green world in the dunes," works best if we remember that the dunes were not erased from existence. They were incorporated into a larger, more habitable mosaic. This also helps explain why the Green Sahara could support such varied animal life. Plant communities are not background scenery for animals. They determine food, shelter, breeding habitat, visibility, shade, and movement routes. Grasses support grazers, shrubs and trees support browsers, wetland plants support aquatic and semi-aquatic food webs. Riverine forests create refuge and corridor habitats. Once the Sahara was clothed in this mixture of open grasslands, woody patches and freshwater margins, it no longer functioned as a vast ecological barrier in the same way it does today. It became, instead, a broad living bridge across North Africa. There is something slightly humbling in that. We often speak of plants as passive things, rooted, silent, decorative, if we're being especially ungrateful. But in stories like this, they are decisive. The return of rain mattered because the plants responded. They spread, stabilized soils, altered albedo, recycled moisture, reduced dust, and provided the biological framework that helped reinforce the greener state. The vegetation was not simply an effect of climate, it became part of the mechanism sustaining the regional transformation. Reviews of the Green Sahara consistently emphasise that vegetation feedbacks were central to land-atmosphere-ocean processes during humid phases. In other words, once the plants arrived, they helped the monsoon keep its footing, and because the plant communities had no exact modern equivalent, they force us to think more carefully about the past. We cannot just point to one present-day biome and say, there, that was the Sahara back then. It was assembled from pieces we still know, but in a combination we do not see now. Open grass dominance, Sahelian wooded taxa, Saharan shrubs, tropical gallery forest species, wetlands and freshwater plant communities all occupied overlapping zones under a climate regime different from today's. That complexity is not an inconvenience, it is the point. The Green Sahara was real not because it matches a modern map, but because the evidence shows a living system that made sense under the conditions of its own time. So if we stand back and picture the ancient Sahara in botanical terms, what we see is not a miracle and not a myth. We see grasslands spread across broad areas, shrubs and thorn trees pushing north, wetland vegetation thickening around lakes, gallery forests tracing rivers and depressions, and ancient desert plants holding on among them. We see a region whose plant cover was productive enough to support movement, settlement, and a dense web of animal life. The sand had not disappeared, but it had lost its monopoly. And once that plant world was in place, it made room for a cast of creatures that sounds almost improbable to modern ears, because the next thing waiting among those grasses, reed beds and lake shores was not just life in the abstract, but a very specific and astonishing collection of animals. There are some phrases so strange they sound like they were invented to test whether anyone is still paying attention. Hippos in the heart of the desert is one of them. A hippo is many things, but subtle is not among them. It is not the sort of animal that can be smuggled quietly into an environment by wishful thinking. If hippopotamuses were living in the Sahara during the African Humid Period, then the Sahara was not merely a little less dry than it is now, it was a fundamentally different world, one with permanent or at least long-lasting water, with enough shoreline vegetation to feed huge semi-aquatic mammals, and with a landscape stable enough to support entire freshwater food webs. Reviews of Saharan environmental history point to exactly that kind of transformation, and a 2023 synthesis notes that early Holocene lakes at Adrabuz, deep in the geographic heart of the Sahara, were home to crocodiles, hippos and Nile perch. That is such a useful fact because hippos do not arrive alone. They imply water of real depth and extent, not a hopeful puddle and a good imagination. Nile perch do not suggest a basin that dries by the weekend. Crocodiles are not a sign that conditions were merely tolerable. Together they tell us that parts of the Sahara held lakes and waterways that were ecologically mature enough to sustain large aquatic animals, fish populations and the dense biological traffic that gathers around them. The same broad humid interval, dated in modern reviews to roughly 15,000 to 5,000 years ago, is described as a time when stronger summer monsoons allowed plants, animals and human groups to move across a Sahara covered in savanna woodland and grassland. That combination of water and vegetation is what turns a barrier into habitat. Once you start with the water, the rest of the animal world begins to make much more sense. Fish were not a decorative detail in this greener Sahara. They were one of the foundations of life around lakes and wetlands. Evidence from central Saharan sites such as Takakori and Gobero shows the importance of aquatic faunas, including catfish and other freshwater species, in environments that are now desert. At Takakori, research on aquatic remains has been used specifically to reconstruct Holocene climate and paleohydrography in the central Sahara, while faunal finds from Gobero include Nile perch and large catfish, along with bones and teeth from hippos. This means the old Sahara was not only wet enough to fill basins, it was wet enough for those waters to function as living systems, with prey, predators, and human fishers taking full advantage of them. Reptiles fit into this picture with almost comical confidence. Crocodiles are among the clearest signs that the Green Sahara was not a brief or fragile mirage. A crocodile can survive hardship, certainly, but it still requires real aquatic habitat, and the presence of crocodiles in early Holocene Saharan lake systems is one of the recurring markers of wetter conditions. Modern research on Saharan crocodiles is striking, partly because a few remnant populations survived in isolated refuges long after the desert returned, like small stubborn footnotes refusing to be edited out of the landscape. Their continued existence in scattered Saharan water bodies today makes sense only if much broader wet phases once allowed crocodiles to spread through the region. During the African Humid Period, the rivers and lakes of the Sahara were not just scenic interruptions in the sand. They were corridors along which aquatic and semi-aquatic animals could disperse. Turtles and aquatic birds add another layer to the scene, and they make the old Sahara feel less like a theoretical climate state and more like a place one could actually stand beside. If you imagine a lakeshore with fish breaking the surface, crocodiles basking nearby, and turtles slipping off muddy edges into the shallows, you're already much closer to the reality suggested by the evidence. At Takakori, aquatic bird remains include pelicans, long-tailed cormorants, and spur-winged geese, and one pelican bone came from an immature bird, which indicates local breeding in the region rather than a mere passing visit. That is an especially vivid detail. A central Saharan landscape dry enough today to punish carelessness once held enough standing water, riparian vegetation, and biological productivity for pelicans to nest there. That is not a minor climate adjustment. That is a continental rewrite. Away from the water's edge, the animal world broadened into something more like a savanna fauna. Prehistoric Saharan rock art, one of the most memorable records of the humid period, depicts abundant elephants, giraffes, hippos, antelope, and aurochs, the wild ancestors of domestic cattle. These images are not important merely because they are beautiful, though many of them are. They matter because they align with the environmental record. They show a Sahara that was not empty and not biologically marginal, but full of large herbivores that require grass, browse, water, and space. A giraffe tells you there were woody plants to browse. Antelope suggest open grazing country and ecotones. Elephants imply landscapes productive enough to sustain very large appetites and the long-distance movement of huge animals. The engravings and paintings make the climate change visible in a way that pollen diagrams, however reliable, rarely manage on first acquaintance. It is worth being careful here not to imagine a single neat herd of Saharan animals trotting obligingly across the same patch of ground for thousands of years. The Green Sahara contained mosaics of habitat, and different animals would have used them differently. Hippos and crocodiles stayed tied to water. Grazers would have tracked the best grasslands after rain. Browsers would have favoured wooded patches and riverine vegetation. Birds would have shifted with nesting opportunities, floodplains, and lake margins. The animal life of the African Humid Period was therefore not just abundant, it was structured. Some species were tied to permanent water, some to seasonal abundance, and some to the wide corridors that opened between once isolated regions when the monsoon pushed north. That is part of why the humid Sahara mattered so much. It was not only rich in species, it was connected in ways the modern desert is not. That connectedness may be one of the most important biological consequences of the whole period. A 2010 PNAS study framed it plainly. During humid phases, the Sahara was not an effective barrier, and both animals and humans populated it. That is a remarkable thing to be able to say about the world's largest hot desert. Under arid conditions, the Sahara divides. Under humid conditions, it links. Watercourses, wetlands and grasslands gave animals routes through what would later become one of the planet's great ecological filters. Species could expand ranges, mix with populations elsewhere, and occupy ground that is now functionally closed to them. When you think of the Green Sahara, it helps not to picture only animals living within it, but animals moving through it, because movement is one of the clearest signs that a landscape has stopped being an obstacle and started being a corridor. You can see that shift even in the kinds of animals people chose to represent. The best-known Saharan rock art does not obsess over the small, furtive, desert-hardened creatures one might expect in the modern landscape. It is full of confidence. Big animals, long legs, horns, heavy bodies, scenes of pursuit, herding, watering, and movement. There is a certain ecological swagger to it. A land that can support elephants and giraffes is not functioning as a marginal environment. It may be seasonal, it may be difficult in places, but it is productive, and it supports enough visible life for people to make that life central to their imagery. Rock art from the African Humid Period has often been described as testimony to a way of life very different from the present desert. That is exactly right. The animals shown are not fantasy decoration. They are ecological witnesses. There would also have been predators, because prey biomass has a way of inviting trouble. One does not fill a continent-sized region with antelope, young water birds, fish, grazing animals at lake margins, and the occasional distracted herbivore without eventually attracting hunters and scavengers. Even if the best direct evidence varies by site and period, the ecological logic is straightforward. A greener Sahara with abundant herbivores and aquatic life would have supported more substantial carnivore communities than the hyper-arid desert of today. Anyone living there would not have experienced it as a gentle zoological garden. They would have known which shorelines were safe at dusk, which water edges belonged more to crocodiles than to people, and which open country offered excellent grazing right up until something faster than you noticed. The Green Sahara was rich, but richness in ecology does not mean harmlessness. Bird life must have been especially striking, even though it tends to receive less popular attention than hippos, for the understandable reason that a pelican, however dignified, struggles to compete with a hippopotamus in sheer conversational force. Yet birds are one of the clearest signs of functioning wetlands. Water birds require feeding grounds, nesting sites, and in some cases riparian trees or vegetated shorelines. The remains from central Saharan sites indicate exactly these conditions. A pelican breeding in the central Sahara suggests not a temporary storm pool, but a water body stable enough to support seasonal cycles of reproduction. Cormorants imply fish-rich waters. Geese suggest shallows and shore habitat. Once you add these birds back into the scene, the old Sahara becomes noisier in the mind. It is no longer only a place of large mammals silhouetted against open ground. It is full of calls, splashes, wing beats, nests, and the constant commotion that water brings. There is also an important practical point hiding in all this animal abundance. Fauna do not merely reveal climate, they shape human opportunity. Fish create predictable food resources, herd animals create hunting possibilities, and later influence herding lifeways. Birds provide eggs, meat, feathers, and seasonal signals. Large herbivores create trails, disturb vegetation, and concentrate nutrients around water sources. Animals are part of how a landscape becomes usable, legible, and worth returning to. When the Sahara turned green, it did not simply become more inhabited by animals in a passive sense. It became more habitable for humans partly because those animals were there. Archaeological work across the Sahara repeatedly ties human occupation to these wetter, richer environments, and the faunal record is one of the reasons we know those occupations were embedded in functioning ecosystems rather than perch precariously on ecological scraps. What I find most striking is how quickly the old certainty of the modern desert begins to dissolve once the animals come into view. A grassland can sound abstract. A monsoon shift can feel technical. Even a paleo lake may still sit at some polite distance in the imagination. But a hippo changes the conversation. A crocodile changes it again. Add pelicans breeding in the central Sahara, giraffes wandering through what is now sand and gravel, elephants moving between watered basins, and fish drawn from lakes in the geographic centre of the desert, and suddenly the old map no longer feels trustworthy. The Sahara stops looking like an eternal absence, and starts looking like a place that has repeatedly changed character, opening and closing to life according to the rhythms of climate and water. By this point, the green Sahara should no longer feel like a desert, with a few surprising animals dropped into it for effect. It was an ecological world in its own right, with food webs, breeding grounds, migration routes, predator-prey relationships, and the sort of everyday biological complexity that makes a landscape feel inhabited rather than merely occupied. The animals of the African Humid Period were not just passing through a lucky interval. Many of them were living inside a stable enough system to leave behind bones, art, middens, and all the stubborn traces that let later scientists reconstruct what had once flourished there. And once those animals were established, they would have become part of daily human experience in ways both practical and cultural, because the next step in the story is not only which creatures lived in the Green Sahara, but how people lived among them, hunted them, fished its waters, followed its seasonal movements, and built communities in a region we now struggle to imagine as home. The first people of the Green Sahara did not arrive in an empty stage set and admire the scenery from a distance. They lived inside a working landscape of lakes, marshes, grasslands, and seasonal movement. They fished its waters, hunted along its edges, buried their dead beside paleo lakes, camped in rock shelters, made pottery, shaped bone tools, and gradually, in some regions, began to build a way of life around domestic animals as well. The archaeological record across the Sahara shows that the humid period supported not just brief visits, but repeated occupation, and in some places fairly intensive or semi-sedentary use of favoured locations. A recent review of the African Humid Period describes the Central Sahara as a region with flowing rivers and permanent lakes that sustained greater intensity of human activity, and probably more sedentary settlement patterns than would have been possible in the later desert. One of the clearest windows into this world comes from Gobero in Niger, a place that is now remote desert but during humid phases lay on the edge of a paleo lake. The site complex preserves one of the richest human records of the Green Sahara. More than 180 burials are known from the central area alone, with the total likely exceeding 200 as work continues. What makes Gobero so important is not only the number of graves, but the long span of occupation, and the way the burials, lake deposits, faunal remains, pollen and artifacts all sit together in one environmental story. This was not a place occupied once and forgotten. It was revisited over thousands of years by different communities adapting to changing conditions around the lake. The earliest well-documented people at Gobero during the humid period were hunter-fisher-gatherers. The PLOS study on the site places this early occupation between roughly 7,700 and 6,200 BCE, when wet conditions attracted groups to the lakeshore and the site served both funerary and habitation functions. In one small area of the site, 17 closely spaced undisturbed burials formed a cemetery, and 5 directly dated graves cluster around about 7,500 BCE. That matters because cemeteries imply repeated use, memory of place, and some degree of social continuity. A group does not create a burial ground by wandering past once with a relaxed attitude toward geography. It returns, remembers, and treats the location as part of its world. Their tools and food remains tell us a great deal about how they lived. Gobero's early Holocene assemblage includes microliths, bone harpoon points, bone hooks, and ceramics with characteristic impressed decoration. The midden fauna is dominated by Nile perch and large catfish, with hippo, crocodile, turtles, bovids, and other animals also represented. The excavators interpret the burial density, toolkit, ceramics, and faunal record as evidence for a largely sedentary population whose subsistence was based on fishing and the hunting of savanna vertebrates. It is a very useful phrase, largely sedentary, because it reminds us that mobility and settlement are not simple opposites. These people may still have moved seasonally or strategically, but they were clearly tied strongly enough to the Paleo Lake to bury their dead there and leave dense traces of repeated use. The image that emerges is of communities who knew water intimately. Fishing in a Saharan paleo lake was not an occasional experiment. Bone harpoons and hooks suggest practiced routines, not improvised curiosity. Large fish such as Nile perch imply substantial oxygenated water bodies. Softshell turtles and crocodiles reinforce the point. This means the first peoples of the Green Sahara were not simply desert foragers taking advantage of a few wet years. In some areas they were specialists in lake-edge subsistence, using ceramics, bone technology, and knowledge of aquatic habitats to build a stable living from waters that no longer exist. The Sahara in this period was not just passable. In places like Gobero it was genuinely livable, and for fishers especially it could be remarkably productive. Gobero also reminds us that these communities were not culturally thin or socially indifferent. The burials are often careful and expressive. One early Holocene man was buried in a tightly flexed pose, and the site as a whole preserves a formal cemetery, rather than isolated accidental graves. Later, during a mid-Holocene occupation associated with the so-called Ternarian cultural phase, there are even more striking burial arrangements, including a triple burial of an adult female and two juveniles laid with intertwined arms, hands and legs. Pollen clusters from flowerheads were found in the sediment beneath them, suggesting they were placed on a floral bedding or mat. It is one of those details that quietly changes the emotional temperature of archaeology. These were not nameless figures passing through a green interval. They were people who cared about burial, gesture, and the handling of the dead. The later people at Gobero were not simply identical to the earlier fisher communities, with slightly different pottery. The PLOS study distinguishes the early Holocene occupants associated with Kiphian material culture from later mid-Holocene occupants associated with Ternarian material culture, and the site preserves evidence for environmental change between these occupations, including episodes when higher lake levels submerged parts of the Paleodune surface. In practical terms, that means the same favoured landscape could become temporarily unusable or require relocation, only to draw people back later under different cultural and ecological conditions. This is exactly what one would expect in a dynamic humid Sahara. Human communities did not live above environmental change. They moved with it, paused during it, and returned when conditions allowed. If Gobero shows us lakeside communities in Niger, Takakori in southwestern Libya shows us a different but equally important version of Saharan life. The archaeological sequence at Takakori spans more than 5,000 years, from hunter-gatherer fishers of the early Holocene through several pastoral phases. The 2024 PLOS study on the site describes early use by later Caicus hunter-gatherer fishers, followed by prolonged pastoral Neolithic occupation. Early levels include fireplaces, stone structures, grinding stones and pottery, all consistent with semi-residential use, and the reconstructed environment includes grasslands, sparse wooded savannas, and permanent freshwater habitats with pondweeds and reeds. This is a very helpful reminder that early communities in the Green Sahara were not all the same. Some were centred on open lake shores, some on rock shelters near watercourses and wetlands, and many likely moved between different kinds of sites across the year. Takakori is especially revealing because the faunal evidence there shows how strongly some communities were tied to aquatic resources. The 2020 PLOS study on the site reports a rich sequence from about 10,200 to 4,650 calibrated years BP, and emphasises that the aquatic fauna can reconstruct both environment and subsistence. Fish remains dominant much of the assemblage, and the study focuses on species that imply connected waterways and wetter conditions in the central Sahara. In plain terms, people were not merely living near water, they were eating from it extensively and building a substantial part of their economy around it. A university summary of the same study states that more than 17,500 animal remains were identified as food waste, and that around 80% were fish. Even allowing for the caution one should always have with summaries, the broader point is secure. Fisher lifeways were central in at least some Green Sahara communities. What is striking about these early Saharan fishers is that they were also potters. The Gubera study notes pottery-producing hunter-fisher-gatherers at Paleolake settings, and the Taka Kori sequence likewise shows pottery, well before any settled farming villages of the type many people associate with the word Neolithic. This matters because it breaks a familiar but misleading chain of assumptions. Pottery does not always arrive with agriculture. In North Africa, as elsewhere, ceramics could belong to mobile or semi-sedentary foragers and fishers who found them useful for boiling, storage or processing aquatic resources. A person standing beside a Saharan lake with a barbed bone point, a net or hook, and a ceramic vessel is already living in a technically capable and environmentally tuned way, even without fields of grain in sight. Over time, however, the archaeological record shows an important shift. In parts of the Sahara, domestic cattle, sheep, and goats entered the picture and were gradually integrated into existing lifeways. Nabta Playa in Egypt is one of the classic Eastern Saharan records for this development. The Journal of Anthropological Archaeology paper on Nabta Playa describes the basin as offering a long view of human-livestock relationships from the early Holocene to about 6000 BP. More recent work on the basin notes hundreds of Neolithic encampments and settlements around the Paleolake. This does not mean the Sahara suddenly swapped fishers for full-time herders in one clean move. Rather, the evidence suggests a long process in which communities in different regions responded differently, combining hunting, fishing, gathering and herding in various proportions. That mixed character is important because the first pastoralists of the Green Sahara were not village farmers in the Eurasian mould. The PubMed abstract for the well-known Nature paper on Saharan dairying states that in the prehistoric Green Sahara, reliance on cattle, sheep and goats emerged as a stable and widespread way of life long before the first evidence for domesticated plants or settled village farming communities. The same study provides chemical evidence for dairying in the 5th millennium BCE from pottery at Taka Kori. In other words, the Sahara developed productive economies centered on livestock, without first passing through the kind of crop-based village agriculture many people expect as the default route to complexity. That tells us something useful about how flexible human subsistence can be when climate opens a large, grassy, seasonally watered world. Taka Kori again gives a particularly clear sequence. The 2024 PLOS study describes hunter-gatherer fishers in the earliest phases, then early, middle and late pastoral occupations marked by cattle and ovicaprine herders. It notes fireplaces, stone structures and human graves in the early pastoral phase. Then a cattle-focused economy with evidence of dairying in the middle pastoral phase, and finally specialised goat herding under increasingly arid conditions in the late pastoral. This is a wonderfully practical record of adaptation. People did not merely suffer climate change, they reworked their economies around it. As water and vegetation patterns shifted, so did the balance between fishing, hunting, cattle keeping, and later more drought-tolerant small stock. Pastoralism in the Green Sahara was not only economic, it was social and symbolic as well. The PLOS study on the Messac Plateau in Libya describes middle pastoral communities building stone monuments and repeatedly depositing cattle, remains in formalised rituals between about 6080 and 5120 BP. The authors interpret this as a highly codified ceremonial system centred on bovines, one that fits into the long African history of cattle as socially important animals, not merely meat on legs. This is a crucial point for understanding early Saharan communities. Once herding became established, cattle were not just calories with horns. They helped organise identity, ceremony, gatherings, and the meanings people attached to landscape and community. The greener Sahara made cattle pastoralism practical, but people then turned it into something cultural and durable. Burial evidence from the eastern Sahara adds still more depth. At Gebel Ramla in Egypt's western desert, an antiquity paper reported the first investigated Neolithic cemetery in that region and linked it to later Neolithic pastoralists practicing transhumance. Later studies from Gebel Ramla described multiple cemeteries, including an unusual cemetery for infants dating to the 5th millennium BCE. Even without dwelling too long on the more delicate parts of that record, the broader significance is plain enough. By the later Green Sahara and its drying margins, some Saharan communities had formal cemeteries, repeated burial customs, and fairly structured pastoral lifeways. These were not people barely hanging on at the edge of habitability. They were organising memory, mobility, family and ritual in ways that left durable marks in the ground. All of this makes it clear that the phrase "first peoples of the Green Sahara" should not conjure a single uniform population with one toolkit and one way of life. The Sahara during the humid period held many local histories. In some areas, hunter-fisher-gatherers with pottery and bone harpoons lived beside lakes. In others, rock shelters document long sequences from fishing and foraging to herding. In the eastern Sahara, paleo-lake basins became focal points for encampments, livestock relations, and eventually formal cemeteries. The human story of the Green Sahara is therefore best understood as a set of regional adaptations linked by climate, water, and movement, not as a single culture spread evenly over the map. That variety is exactly what one would expect across such a vast and environmentally diverse region. It is also worth noticing how often these communities chose edges: lake margins, shelter mouths, basin floors, paleodune ridges, wetland borders, drainage lines. People are edge specialists by temperament as much as by necessity. A pure desert interior gives little to work with. A pure marsh can be inconvenient in other ways unless one is a reed and has strong feelings about standing water. But the edge between dry and wet, open and sheltered, aquatic and terrestrial, is where options multiply. That is where fish are close, grazing is accessible, birds gather, wood can be collected, and visibility can still be managed. Archaeology in the Green Sahara repeatedly returns to these edges, because edges are where people make living landscapes out of climatic opportunity. The recent ancient DNA work from Takakori adds one more caution against oversimplifying this story. A 2025 Nature study, summarised by the Max Planck Institute, found that 2 naturally mummified individuals from Takakori belonged primarily to a long isolated North African lineage, and suggested that pastoralism in the Green Sahara may have spread more through cultural exchange than large-scale migration. That does not overturn the archaeological picture of mobility and contact, but it does remind us that ideas, animals and practices can move differently from people. Herding can spread without whole populations being replaced. Communities can remain biologically distinct while still adopting new economies. The Sahara, even when green, was not a single melting pot. It was a wide field of contact, borrowing, persistence and local continuity. So when we try to picture the first peoples of the Green Sahara, it helps to resist 2 temptations. The first is to imagine lonely survivalists scattered thinly across a barely habitable land. The evidence does not support that. The second is to imagine a simple march from primitive fishers to advanced herders, as though history had only one lane and everyone politely stayed in it. The evidence does not support that either. What we see instead are communities tuned to water, season, and place. Some fished deep lakes with bone harpoons. Some hunted and gathered around wetlands and wooded grasslands. Some combined older foraging traditions with newer livestock economies. Some buried their dead in cemeteries beside paleo lakes. Some built stone monuments and shaped ceremonial worlds around cattle. Together they make the Green Sahara feel properly human, practical, adaptive, inventive, and never quite as tidy as a textbook diagram would prefer. And that human record matters for another reason as well. These people did not leave us only bones and tools, they left patterns. Burial grounds in the wrong place for a desert, pottery carrying milk fats where now almost nothing grows. Fish remains far from modern waters. Monumental traces tied to herders in what is now stony emptiness. Each of those is a clue, and together they show how archaeology works when the land itself has changed so completely that ordinary intuition stops being useful. Once you begin following those clues seriously, the next question naturally shifts from how these people lived to how we know any of this at all, because beneath the sand lie not just graves and camps, but an entire archive of evidence waiting to be read. Once the people of the Green Sahara begin to feel real, the next question changes. It is no longer only who lived there or what animals moved through that wetter world. It becomes something more practical. How do we know? How does archaeology work in a place where modern appearances are so misleading that a dry basin may once have been a lake, a dune ridge may hide a cemetery, and a rock shelter in today's desert may preserve thousands of years of human activity from a time when grasslands, wetlands, and permanent freshwater were part of ordinary life? In the Sahara, archaeology is often an argument against the present tense. The surface says arid emptiness, but excavation, dating, faunal analysis, archaeobotany, and rock art studies keep producing the same reply. Beneath the sand are repeated traces of occupation tied to humid intervals, including lakeside burials, settlements, pottery, fish remains, livestock evidence, and long site sequences at places such as Gobero in Niger and Takakori in Libya. One of the clearest examples is Gobero at the western edge of the Ténéré Desert in Niger. There, archaeologists documented approximately 200 burials adjacent to a paleo lake, with a minimum of 182 already preserved in the central area alone, and the total likely to exceed 200 as exploration continues. The site preserves two main occupational phases linked to humid intervals, reconstructed with 78 direct AMS radiocarbon dates on human remains, fauna, and artifacts, along with 9 OSL dates on paleo-dune sand. The early phase belongs to largely sedentary hunter-fisher-gatherers between about 7,700 and 6,200 BCE, while a later mid-Holocene phase followed after an arid interruption. That kind of chronology matters because it turns a romantic story about a green desert into a measured history with dates, gaps, returns, and environmental change recorded directly in the ground. A site like Gobero does not just show that people were there, it shows when they came, when they left, and how climate helped shape both. Burials are especially powerful evidence because they carry social meaning in addition to chronology. Gobero preserves what the excavators describe as the earliest recorded cemetery in the Sahara, dating to around 7,500 BCE, and the site shows that this was not an accidental scattering of dead individuals but a repeated funerary landscape. Some early burials are tightly hyperflexed, while later ones include more elaborate grave goods and striking body arrangements. One famous mid-Holocene triple burial consists of an adult female and 2 juveniles laid with intertwined arms, hands and legs, suggesting they were buried together in an intimate pose. Pollen clusters from the flower celosia were found beneath them, implying floral bedding or a mat placed under the bodies. That is archaeology at its most quietly persuasive. A skeleton can tell you someone died. A burial ground tells you a place mattered. Flowers beneath a burial tell you memory, care, and ritual were already fully present on the shore of a Saharan paleo lake, now surrounded by desert. Artifacts deepen that picture because they reveal the practical routines of life, rather than only its endings. At Gobero, archaeologists recovered microliths, bone harpoon points, bone hooks, and ceramics with dotted wavy line and zigzag impress motifs from burial fill, refuse areas, and nearby Paleolake deposits. Direct dates on bone harpoons and plant temper from Kiffian pottery confirm that these objects belong to the early occupational phase. The associated midden fauna is dominated by Nile perch and large catfish, and also includes hippo, crocodile, softshell turtle, bovids, and small carnivores. The excavators interpret the burial density, tools, ceramics, and faunal remains together as evidence for a largely sedentary population, living by fishing and by hunting a range of savanna animals. That is a very useful correction to the lazy image of prehistoric Saharans as endlessly wandering in desperation. In at least some places, they were settled enough to accumulate tools, middens and graves in dense lakeside settings. Takakori, in the Tadrot Acaicus of southwestern Libya, offers a different but equally important kind of record. Its archaeological sequence spans more than 5,000 years, from early Holocene hunter-gatherer fissures known locally as late Acaicus to successive early Middle and late pastoral Neolithic occupations. Excavation there revealed stone structures, fireplaces, grinding stones, potsherds, and in later phases human graves and abundant evidence of herding. The site's environmental reconstruction includes grasslands, sparse wooded savannas, and permanent freshwater habitats with pondweeds and reeds during its earlier phases, followed by increasing aridity and the spread of xerophytic plants in later periods. This long sequence matters because it shows continuity and adaptation in one place. Instead of a snapshot, Takakori offers a film. You can watch a shelter move from the world of fishers to the world of cattle herders, and later small stock specialists as the climate becomes less generous. The faunal record at Takakori is especially revealing because it shows how strongly some Saharan communities were tied to water. The site's earliest inhabitants, dated to roughly 10,000, 200 to 8,000 calibrated years BP, are described as hunter-gatherer fishers, and archaeological as well as archaeobotanical evidence indicates prolonged, though seasonal, residential occupation. Stone structures, large fireplaces, grinding stones and abundant pottery all support a semi-sedentary lifestyle. The aquatic fauna from the shelter has been used to reconstruct Holocene climate and paleohydrography, and a university summary of the research reports more than 17,500 animal remains identified as food waste, about 80% of them fish. That combination of evidence is hard to argue with. You do not get it from brief camping beside a puddle. You get it from people who know a freshwater system well enough to build a recurring occupation around it. Pottery is one of the most important clues in this entire story, because it tells us something about daily practice as much as chronology. At Nabta Playa in Egypt's western desert, dated and stratified potsherds belong to what antiquity describes as the earliest phase of pottery making in the Sahara, including relatively sophisticated bowls decorated with a toothed wheel. Elsewhere in the Sahara, pottery appears among hunter-fisher-gatherers long before settled farming villages of the sort people often assume must come first. That matters because it breaks a familiar habit of thought. Ceramic technology does not belong only to farmers. In the Green Sahara, fishers and mobile or semi-residential communities use pottery too, likely for boiling, storage, and processing food. Nabta Playa is also important because its long sequence, from about 11,000 to 6,000 BP, offers an unusually clear record of changing human-livestock relationships and the emergence of more complex pastoral life. Archaeology also reveals not only what people ate, but how they changed what they ate. Gobero's later middens contain clams, fish, wild bovids, and domesticated cattle, indicating a broader and more flexible subsistence economy than the earlier fishing-heavy phase. At Takakori, the sequence moves from fisher-foragers to the earliest pastoral Neolithic herders, around 8,300 cal BP, and then to a full pastoral economy centered on cattle exploitation, including dairying, by roughly 7,100 col BP. direct chemical analysis of pottery has strengthened this picture even further. A 2020 PNAS study reported molecular and isotopic evidence for milk, meat, and plants in archaeological ceramics from the Sahara, and earlier Nature work identified the 5th millennium BCE pottery from Takakori as the earliest direct chemical evidence for dairying in Africa. Archaeology, in other words, now reads vessels almost the way a detective reads fingerprints. A pot is no longer just a pot. It is a record of what simmered inside it. Rock art adds another layer, although it has to be handled with a little more caution than people sometimes assume. The Saharan massifs are covered with thousands of painted and engraved artworks on open-air boulders, cliffs, and the walls of shelters and caves, and rock art remains the best-known evidence of Saharan heritage. Yet good archaeology has moved past treating these images as isolated wonders. Modern work places them in context, linking them to deposits, dates, styles, environmental change, and local settlement histories. The same review that emphasises the sheer abundance of Saharan rock art also stresses that recent research uses indirect dating methods and contextual approaches to place the images more securely within archaeological time. That matters because an engraving of cattle or wild fauna is not useful simply because it is beautiful. It becomes most useful when tied to occupation phases, surface weathering, associated deposits, and a wider regional sequence. Seen in that light, rock art becomes much more than an illustration. It reveals environmental, socio-cultural, and ideological dynamics that archaeology might otherwise miss. In the central Saharan massifs, pastoral or Bovidian rock art is the most common type, with thousands of sites across the Sahara showing domestic cattle and pastoral life. Scenes include daily activities, herd management, milking, hunting, and ritual. These are not merely pretty additions to a climate story, they show how people understood animals, labour, and social life once pastoral economies became established. At the same time, the history of rock art research itself is a cautionary tale. Early reproductions and recording methods were pioneering, but some later came under criticism for damaging the paintings. More recent work has become more careful, using multidisciplinary approaches, radiocarbon-linked contexts, pigment analysis, and conservation studies. Even archaeology has its own archaeology, and the desert keeps reminding researchers to be humble with fragile evidence. A great deal of what archaeology reveals in the Sahara depends on method rather than spectacle. Radiocarbon dating gives the backbone of site chronology. OSL dating can determine when paleo-dune sands were last exposed to light. Pollen and phytoliths reveal whether a burial ground stood in open grass savanna near wet habitats or in a drying semi-desert. Faunal analysis shows whether people were eating fish, clams, bovids, or herding cattle and goats. Sediment layers reveal lake expansion, inundation, and abandonment. At Gabbero, the chronology rests on direct dating of humans, fauna, artifacts, and paleo-dune sands. At Takakori, a stratified sequence secured by many radiocarbon dates lets archaeologists distinguish early fissure phases from later pastoral ones. This is what makes Saharan archaeology so compelling. The finds are evocative, certainly, but the strength of the case comes from many lines of evidence agreeing with one another in the same places. Newer methods have extended that archive even further. In 2025, the first ancient genomes from the Green Sahara were published from 2 naturally mummified individuals from Takakori. The Nature paper and accompanying Max Planck summary describe Takakori as preserving a timeline from later Caicus hunter-gatherer fissures around 10,200 cal-BP through a long pastoral Neolithic occupation ending around 4,200 cal-BP. The genomic results pointed to a deeply rooted North African lineage and suggested that, in this case, pastoralism may have spread more through cultural transmission than through large-scale population replacement. That is a striking example of how archaeology in the Sahara now works across scales. The same site can yield fireplaces, potsherds, dung layers, fish bones, burials and genetic data, all from a shelter that today looks out on an arid landscape with very little to suggest such richness at first glance. There is something very fitting about the fact that the Sahara requires this many methods to be understood. A desert is good at concealment. Sand buries, wind deflates, surfaces erode, lake margins disappear, and what survives often does so in fragments. Yet that same dryness can preserve things remarkably well when conditions are right. A paleodune can hold a cemetery. A shelter floor can preserve hearths, dung, grinding stones and stratified occupation. A midden can keep fish vertebrae stacked beside potsherds. A burial can preserve pollen and ornaments. A painted shelter wall can outlast the climate that made its scenes imaginable. Archaeology in the Green Sahara therefore becomes a matter of assembling memory from stubborn leftovers. Stone, bone, potsherd, pigment, pollen, residue, sediment, and now DNA all contribute a piece. None is enough on its own. Together they make the old landscape difficult to deny. By the time all of that evidence is placed side by side, the modern desert stops being the obvious interpretation and becomes the late outcome. The Sahara's buried cemeteries, fish-rich middens, decorated pottery, cattle ritual, rock art, and long shelter sequences all say the same thing in different forms. This land supported repeated human occupation when climate, water, and vegetation allowed it. People did not merely cross it. They lived within it, adapted to it, buried their dead in it, and left behind enough traces for us to reconstruct both ordinary routines and larger shifts in economy and belief. Archaeology is what makes that reconstruction possible, but it also leaves us with one unavoidable question. If the ground is full of evidence that the Sahara once held lakes, fishers, herders and cemeteries, then we eventually have to ask why that living world began to narrow, dry and break apart in the first place. If the Green Sahara feels surprising when we meet it through lakes, fish, burials and hippos, it becomes even more interesting when we ask why it began, because the answer does not start on the ground. It starts above the ground and then farther out than that. It starts with the sky, with summer sunlight, with the timing of the seasons, and with the slightly unsettling fact that the habitability of a continent can depend in part on the way Earth tilts and wobbles as it moves around the sun. That sounds almost too grand to be useful, as though we have wandered out of archaeology and into celestial bookkeeping. But in climate science, this is often how the deepest changes begin. A lake in the Sahara may owe its existence in part to geometry. A grassland may begin with orbital timing. The rain that once fell across North Africa was not random. It was encouraged by a planetary arrangement that made Northern Hemisphere summers stronger and the African monsoon more ambitious than it is today. The first piece of the story is precession, which is a polite scientific word for one of Earth's slow wobbles. Earth does not spin in a perfectly fixed orientation forever. Over long stretches of time, the direction of its axis slowly changes, rather like a spinning top that never quite settles. This wobble affects when the seasons happen relative to Earth's position in its orbit around the Sun. At some times in the cycle, Northern Hemisphere summer occurs when Earth is receiving relatively stronger summer sunlight. At other times, the seasonal contrast is weaker. North African humid periods are now widely understood to be paced by this precession cycle, and the broad pattern is clear. When Northern Hemisphere summer insolation is stronger, the African monsoon tends to intensify and push farther north. When that summer forcing weakens, the monsoon retreats and aridity returns. The Green Sahara of the Holocene fits squarely into that larger rhythm. That stronger summer sunlight mattered because land and ocean do not heat in the same way. Land warms faster than water. Give North Africa a stronger summer sun, and the continent heats up more sharply than the adjacent tropical Atlantic and nearby ocean waters. Warm air rises over the hot land surface, pressure drops, and moist air is drawn inland from over the ocean. That is the essence of the monsoon mechanism. It is not just rain arriving for mysterious reasons. It is a large seasonal circulation built from temperature contrast, pressure gradients, and moisture transport. During the African Humid Period, increased summer insolation strengthened that contrast and helped the summer rain belt move much farther north into areas that are now beyond its reliable reach. In simple atmosphere-only climate experiments, increases in summer radiation comparable to those of the humid period lead to large increases in African monsoon rainfall, and the response grows stronger still when ocean feedbacks are included. That northward movement of the monsoon is really the hinge on which the whole story turns. Once the rains reach farther north, the map of possibility changes. Seasonal ponds begin to persist. Depressions fill, drainage networks reactivate, grasses spread where bare ground had dominated, wetlands establish themselves around shallow water, lakes expand. In a modern climate atlas, the boundary between the greener Sahel and the drier Sahara can look almost like a fixed line, something nature drew once and never revised. But the humid period reminds us that the line moves. It can move a little, or a great deal, depending on the larger climate system. During the Green Sahara, the line moved far enough north to change not just local conditions, but the basic ecological structure of much of North Africa. A rainfall boundary became a continental reorganization. Still, if the story ended there, climate scientists would be less tired than they are. Stronger summer sunlight explains the push, but not the full scale of the result. For many years, climate models struggled to reproduce a Sahara as green and wet as the geological and archaeological evidence clearly indicated. Proxy records showed lakes, vegetation, reduced dust, and broad monsoon expansion, yet models driven by orbital forcing alone often came up short. That mismatch turned out to be useful because it revealed that the humid period was not powered by sunlight alone. It depended on feedbacks inside the climate system itself, especially involving vegetation, dust, and land surface change. In other words, once the rains began to move north, the land started helping the process along. Vegetation was one of the most important of these amplifiers. Bare desert and living plant cover behave very differently under the sun. Desert sand reflects more sunlight, while darker vegetated surfaces absorb more. Plants also release moisture back to the atmosphere through evapotranspiration, helping to recycle water and affect local humidity. Once grasses, shrubs, and trees spread across parts of the Sahara, they did more than respond to rain. They altered the land surface in ways that could support additional rainfall and strengthen monsoon effects. This kind of vegetation-climate feedback has been a central part of Green Sahara research for years, and newer modelling work continues to show that vegetation is essential if we want simulations to come close to the greening suggested by proxy evidence. The landscape was not simply being watered from above, it was becoming more capable of holding onto and reinforcing that wetter state. Dust was another surprisingly powerful actor in the story. The modern Sahara is one of the great dust sources on Earth. Dry, sparsely vegetated ground gives wind plenty to lift and carry, and Saharan dust today affects climate and ecosystems far beyond Africa. During the African Humid Period, however, a greener and wetter Sahara would have produced far less dust in many areas. That matters because dust influences how much solar radiation is absorbed or reflected, and can affect clouds and atmospheric circulation. A 2016 modelling study found that reducing Saharan dust strengthened vegetation albedo feedbacks and pushed the monsoon's northern limit about 500 kilometres farther north than vegetation change alone. That is an enormous distance. It means the old Sahara did not just receive more rain and then look greener. Its reduced dustiness may have helped the monsoon penetrate deeper into the continent than it otherwise could. So the beginning of the humid period is best understood not as a single cause but as a chain. Orbital precession increased northern hemisphere summer insolation. That strengthened summer heating over North Africa. Stronger heating intensified the monsoon and drew more Atlantic moisture inland. More rain supported vegetation. More vegetation altered the land surface and helped recycle moisture. Reduced dust further amplified the northward reach of monsoonal rains. Each step made the next more effective. This is one reason the Green Sahara can look so dramatic in hindsight. Climate systems are not shy about using feedback loops when given the chance. Once conditions cross the right threshold, change can become self-reinforcing for a while, and the result on the ground can be much larger than the initial orbital nudge might lead a casual observer to expect. There is also an important role for the wider background climate, especially ice sheets and glacial boundary conditions. Not every precession minimum produces the same humid response. A 2023 Nature Communication study that simulated 20 North African humid periods over the past 800,000 years found that precession determines their pacing, but their amplitude is strongly linked to eccentricity through its control over ice sheet extent. During glacial times, even when precession favours stronger summer insolation, large ice sheets and the cooling associated with them can suppress the humid response. In plainer terms, the monsoon may be invited north by summer sunlight, but if the broader climate state is too cold or too burdened by glacial conditions, the invitation is not fully accepted. The Holocene humid period happened in a deglacial and then interglacial context, when the retreat of ice sheets and changing greenhouse conditions allowed the monsoon response to be much stronger. That broader context helps explain why the early Holocene was such fertile ground for a greener Sahara. The last ice age had ended. Massive northern hemisphere ice sheets were retreating. Atmospheric carbon dioxide was rising from glacial lows. The background climate was reorganizing toward warmer interglacial conditions. Into that setting came the orbital configuration favoring stronger northern hemisphere summer insolation. It was, in climate terms, an aligned moment. The monsoon did not have to fight uphill against the coldest boundary conditions. It was operating in a world already opening up to warmth and hydrological change. That combination helps explain why the African humid period was so extensive during the early and middle Holocene compared with many drier intervals before and after. One of the more interesting and slightly mischievous aspects of the whole process is that the forcing from orbit changed gradually, but some parts of the humid response appear to have begun quickly. The classic 2000 Domenical paper argued that although the humid period is associated with gradual orbital increases in summer insolation, both its onset and termination could be abrupt, taking place over decades to centuries in some records. That is an important reminder that climate systems do not always respond in smooth, polite curves. A slow shift in forcing can push a system toward a threshold, and then the visible environmental change can happen much faster once that threshold is crossed. Lakes can fill, vegetation can expand, dust can collapse, and the atmosphere can reorganize in ways that look sudden compared with the slow, celestial pacing that set the stage. This threshold behavior is one reason researchers sometimes talk about the Sahara as having more than one stable mode. Under one set of conditions, it can remain dry, bright, and dusty, with little vegetation and weak monsoon penetration. Under another, it can become greener, darker, less dusty, and more supportive of rainfall. A recent PNAS study described evidence for a North Africa land atmosphere bistability during the Holocene, meaning the region may have had two contrasting states that the system could occupy under different conditions. That does not mean the Sahara behaved like a light switch in every place at every moment. Real landscapes remain patchy, but it does mean the broad regional system may have been capable of fairly rapid shifts once enough reinforcing processes lined up. Climate, in this case, was not just a dimmer knob. At times it may have behaved more like a latch. Ocean feedbacks likely helped as well. The monsoon does not draw moisture from a theoretical ocean. It draws from real tropical waters whose temperatures affect evaporation and atmospheric circulation. Studies and reviews of the African humid period emphasize that stronger summer insolation alone is often not enough in models to generate the full monsoon response unless ocean feedbacks are allowed to contribute. Warmer sea surface conditions in the tropical Atlantic can support stronger moisture supply, while broader changes in ocean circulation influence how heat is distributed and how the atmosphere responds. In that sense, the Green Sahara was not produced by North Africa acting alone. It was part of an interlinked ocean-atmosphere land system, with the Atlantic helping to provide the moisture and the continent helping to decide how far inland that moisture could go. There is also a useful practical way to think about it. Imagine North Africa under stronger early Holocene summers. The land heats more aggressively. Rising air over the continent becomes more pronounced. Moist air is pulled farther inland. Seasonal rains arrive more reliably and farther north. Grasses respond first in many places, then shrubs and trees where conditions allow. Dust emissions decline because the ground is no longer so exposed. The darker, rougher, moister land surface changes how the atmosphere behaves. Lakes and wetlands expand. A region that had been difficult or impossible for many forms of life becomes a patchwork of opportunity. None of this requires a miracle. It requires only enough nudging of a sensitive monsoon system, followed by feedbacks that know exactly how to magnify small beginnings into large landscapes. What I find especially useful about this explanation is that it makes the Green Sahara feel less like a contradiction and more like a natural mode of the Earth system. The desert we know is not the only real Sahara. It is the version produced under current orbital and climatic conditions. Change the seasonal insulation, reduce glacial constraints, strengthen the monsoon, add vegetation and dust feedbacks, and another Sahara appears, just as real and just as physical. It is full of lakes, wetlands, grasslands, fishers, herders, crocodiles, and rock art because the sky above it is operating under a different seasonal arrangement. That is the quiet lesson underneath the science. Continents are not static characters. They are negotiations between sunlight, air, water, land, and time. There is, however, one detail that keeps the story from becoming too tidy, and it is this. The same forces that helped begin the humid period also ensured it would not last forever. Precession keeps moving. Summer insolation does not hold still out of kindness toward pelicans, fishers, or anyone else. As the orbital geometry changed, the favourable alignment for strong northern hemisphere summer heating began to weaken. The monsoon's reach, which had once pushed deep into the Sahara, would eventually begin to falter. And because the green estate relied not just on rain, but on feedbacks from vegetation and dust, a weakening from above could eventually begin to unravel the support system from below. So even while the humid period was being built, the longer clock of its decline was already ticking in the background, waiting for the rains to lose their hold. No green landscape lasts forever simply because life has grown comfortable in it. The same seasonal machinery that once pushed the rains far into the Sahara eventually began to weaken. Northern Hemisphere summer insolation declined as Earth's orbital configuration kept changing, and with that gradual change the African monsoon began to lose some of the reach it had enjoyed during the humid period. In the broadest sense, that is why the drying began at all. The atmosphere was no longer being pushed as strongly toward that wetter state, but the actual decline on the ground was not as simple as drawing one smooth line from green to brown. For many years, scientists argued over whether the Sahara dried abruptly, almost like a climatic switch being thrown, or gradually, like a long withdrawal of water and vegetation over many centuries. The reason for that debate is that the evidence seemed to point in both directions depending on where one looked and what exactly one was measuring. One of the strongest early cases for abrupt drying came from marine sediments off the coast of Mauritania. In that record, terrigenous dust deposition changed very sharply, and Demenical's influential 2000 study argued that the onset and termination of the African Humid Period were very abrupt, happening within decades to centuries, even though the orbital forcing behind them changed much more slowly. That result became famous because it seemed to show a climate system capable of flipping quickly once important thresholds were crossed. It also fit nicely with the idea that land surface feedbacks in North Africa, especially involving vegetation and albedo, could turn a gradual weakening of summer insolation into a much more sudden ecological collapse. It was a compelling picture, and for a while the end of the Green Sahara was widely discussed as one of the classic examples of abrupt climate change in the Holocene. Then other records complicated that picture, which is often how science rewards anyone who becomes too emotionally attached to a tidy explanation. Lake Yoa in northern Chad turned out to be especially important because it preserved one of the few continuous sediment records from within the Sahara itself. The work summarised by Crocodile and colleagues showed that drying in the regional terrestrial ecosystem that was progressive rather than instant, developing between about 5,600 and 2,700 years ago. The vegetation changed in a sequence that makes ecological sense. Tropical grassland trees and herbs gave way to more typical Sahelian vegetation. Then grass cover declined further, and eventually the modern desert plant community became established. At the same time, the lake's own aquatic system changed much more abruptly, shifting from fresh water toward hypersaline conditions between about 4,200 and 3,900 years ago as the water balance deteriorated. That distinction is crucial. A local water body can cross a threshold suddenly, while the surrounding land vegetation may be responding over a much longer interval. In other words, the Sahara's drying could be both gradual and abrupt, depending on what part of the system you were asking about. That helped move the discussion away from the question of whether the end was abrupt or gradual in some absolute sense, and toward a more useful question. Where, and for which proxy, was it abrupt, and where was it slow? By 2015, Shanahan and colleagues argued that the termination of the African Humid Period was time transgressive. Their synthesis of hydrologic reconstructions from across Africa concluded that the ending was locally abrupt in some places, but that it occurred progressively later at lower latitudes. They proposed that this reflected declining rainfall intensity, driven directly by decreasing summer insolation, together with the gradual southward migration of the tropical rain belt. That is a very elegant way of saying the monsoon did not retreat everywhere at once. Places farther north generally lost their wet conditions earlier than places farther south, and what looked like a single event in older summaries was in fact a shifting belt of drying moving across space and time. Later modelling work reinforced that regional complexity. A 2020 transient Earth system model, studied by Dallmeyer and colleagues, found that reconstructions reveal an end to the humid period that was earlier in the north than in the south, and earlier in the east than in the west. The model reproduced that broad pattern and suggested it came from regionally different controls on precipitation. In parts of West Africa and the Western Sahara, moisture could still be sustained for longer because of interactions involving extra-tropical troughs and seasonal circulation patterns, whereas lower latitude West Africa followed the southward retreat of the monsoonal rain belt more directly. This matters because it means the drying was not just a simple shrinking puddle. Different parts of North Africa were fed by different seasonal rainfall mechanisms, so they did not all fail at the same pace. The end of the Green Sahara was therefore not a single synchronized collapse seen equally from Mauritania to Egypt. It was a staggered unravelling. There is also the question of what actually tipped some regions into faster decline. One proposed mechanism comes from a 2017 Nature Communication study by Collins and colleagues, which found evidence for a rapid drop in precipitation between about 5.8 and 4.8 thousand years ago in records from the Gulf of Guinea, and linked this to a larger atmospheric mechanism. Their argument was that northern high and mid-latitude cooling weakened the tropical easterly jet, and, through feedbacks, strengthened the African easterly jet, reducing precipitation and helping trigger aridification. That idea does not replace the orbital explanation. Rather, it adds a possible trigger or accelerator during the weakening phase of the humid period. It suggests that even relatively modest extratropical temperature changes could have helped push parts of the African climate system toward a faster drying response once the monsoon was already under declining insolation forcing. Climate systems are rarely content with one cause when three interacting causes will do. On the ground, This long drying would not have looked like a single apocalyptic season, after which everyone woke up and found sand where breakfast used to be. It would have been experienced as the growing unreliability of familiar things. Lakes that once refilled confidently after the rains would shrink more often, or remain lower for longer. Marsh margins would retreat. Grass would still come in good years, but fail more often in poor ones. The spacing between dependable water sources would increase. River channels that had carried seasonal flow would run less frequently or for shorter periods. Trees tied to wetter conditions would thin out in some areas, while more drought-tolerant species expanded. Dust, which vegetation and soil moisture had once suppressed, would begin to rise again from increasingly exposed surfaces. The Sahara did not need one dramatic final act to become hostile. It only needed enough years, enough generations, and enough repeated disappointments in rainfall for the living structure of the region to start coming apart. This is where the distinction between hydrological and ecological change becomes especially important. A lake can disappear in what is, geologically speaking, a fairly short time if its water balance crosses a critical threshold. Vegetation, by contrast, may show inertia. Some plant communities can hang on under declining rainfall for a while, especially in refuges, along groundwater-supported zones, or in areas with local topographic advantages. Human perceptions of change would vary accordingly. A fisher might notice first that a favoured lake was no longer dependable. A herder might see the problem in shrinking dry season grazing. Someone living near a river corridor might think conditions were still manageable, long after open grassland beyond it had already begun to fail. This is one reason the archaeological record preserves so many different local histories near the end of the humid period. Not all communities were being squeezed in exactly the same way, or on exactly the same timetable. Dust records, however, make it very clear that the broader regional system was shifting. As vegetation declined and formerly stabilised surfaces became exposed again, wind erosion intensified. The offshore dust record used by Domenical showed a sharp increase in terrigenous input after the humid period, while later work on North African and Saharan records has continued to treat dust as one of the clearest signs that the desert state was re-establishing itself. Once enough bare ground returned, the Sahara began to recover one of its defining modern roles as a major dust source. That is more than a side effect. Dust changes how much sunlight is reflected and absorbed, interacts with clouds, and marks the return of an atmospheric regime very different from the greener, less dusty Sahara of the humid period. The land was not only losing water and vegetation, it was regaining the self-reinforcing physical character of a desert. The human significance of this would have been enormous, though the full story belongs with what came next. As the humid system weakened, places that had once supported semi-sedentary fishing communities, wetland exploitation, or broad cattle-based pastoralism would have become more difficult to use in the same way. The University of Cologne's summary of the Lake Yoa work, drawing on related Saharan research, notes that as the Sahara dried, many pastoralists and farmers retreated toward the present-day Sahel and the Nile Valley. That makes intuitive sense. As dependable water and grassland contracted southward or became concentrated in fewer refuges, people would have followed the shrinking geography of possibility. The Green Sahara did not end only as an environmental event, it ended as a reorganization of human space. Entire ways of moving, grazing, fishing and inhabiting the land would have had to change in response. There is a tendency to imagine the drying of the Sahara as a clean reversal, as though nature simply undid what it had done before, but reversals are never that neat. The wet phase had built lakes, soils, vegetation mosaics, animal distributions, travel routes, burial grounds, and pastoral landscapes. Drying did not erase all of that at once, it fragmented it. Some wetlands vanished early, some groundwater-fed refuges held on. Some regions retained relatively favourable conditions after others had already crossed into much harsher aridity. Even today there are scattered pockets in the Sahara whose existence makes more sense when you remember the old wet phases behind them. A few remnant water bodies, some surviving plant refugia, and the occasional relict fauna all hint that the desert did not descend like a uniform curtain. It advanced unevenly, leaving isolated traces of the old world behind. That unevenness may be why the end of the Green Sahara feels so compelling. It was neither a simple slow fade nor a single sudden crash. It was a long drying with episodes of sharper change, different in timing from one region to another, and different in expression depending on whether you looked at dust, lake chemistry, vegetation, or human settlement. The rains began to fail because the orbital support for a strong monsoon was weakening, but what followed depended on thresholds, feedbacks, and geography. Some lakes crossed their limits abruptly, some landscapes dried over millennia, some parts of the west held moisture longer than parts of the east. North generally turned dry before lower latitudes. What had once been a broad living corridor across North Africa gradually narrowed into a more broken set of habitable zones. And once that narrowing began, every species living in the Green Sahara, including our own, had to decide whether to adapt, to move, or to disappear from places it had once called home. When the rains began to fail, life in the Sahara was not confronted with a single dramatic instruction to leave. It was confronted with a growing shortage of certainty. Water that had once been reliable became seasonal. Seasonal water became intermittent. Intermittent water became memory. That kind of change matters because living things do not respond only to climate averages. They respond to whether the next lake still fills, whether the dry season lasts a little longer than before, whether the grass returns on time, whether the marsh edge is where it used to be, whether the familiar route between water sources still works. Records from Lake Yoa in northern Chad show that the regional ecosystem dried progressively over thousands of years, with tropical grassland trees and herbs giving way to Sahelian vegetation, and then to the modern desert flora, while the lake itself shifted from freshwater toward hypersaline conditions much more abruptly between about 4,200 and 3,900 years ago. That contrast is a good place to begin, because it shows that the old Green Sahara did not vanish all at once. Different parts of the living system failed on different clocks. Plants were often the first visible sign that the land was losing its old generosity. A grassland can survive a poor year. It can even survive several difficult years if seeds remain in the soil, and wet seasons still return often enough. But once the monsoon kept retreating and dry spells lengthened, the broad green cover that had tied the humid period Sahara together began to fragment. At Lake Yoa, the vegetation sequence shows a steady ecological succession rather than a single instantaneous collapse. More moisture-demanding taxa declined, Sahelian communities took over, and eventually the desert flora we now associate with the region became established. That means the old grassy and wooded Sahara did not simply disappear under a wave of sand in one human lifetime. It thinned, retreated, and reorganized. Some plants disappeared from large areas, others held on in favored local settings. Drought-tolerant shrubs and desert species expanded into spaces that had once supported a richer mix of grassland, wetland, and wooded vegetation. That gradual botanical retreat would have changed the entire feel of the land. Open grazing grounds would have become patchier. Reeds and wetland plants around shrinking lakes would have narrowed into thinner belts. Trees tied to more dependable water, especially those along old rivers or lake margins, would have been forced back into refuges. A landscape does not need to lose every plant to stop functioning as a grassland world. It only needs to lose enough continuity. Once the green cover breaks into disconnected patches, animals that depend on that continuity begin to pay the price. What had once been one large navigable ecological fabric becomes a set of islands separated by increasing dryness. In a place as large as the Sahara, fragmentation is often more decisive than outright disappearance, because a scattered resource is not the same thing as a usable landscape. Animals tied directly to water were among the most vulnerable. Fish, crocodiles, turtles, hippos, and water birds could persist only where lakes, wetlands, or connected channels remained deep and stable enough to support them. At sites such as Gobero and Takakori, the humid period faunal record had included fish-rich diets and large aquatic species, but those possibilities depended on functioning freshwater systems. As the lakes shrank, salinity changed and channels failed, aquatic habitats collapsed from networks into refuges. That did not always mean every species vanished everywhere at the same time. Some water bodies lasted longer than others. Some were fed by groundwater and persisted after surface runoff had weakened. But the broad connected freshwater world of the humid Sahara could not survive once the hydrological system began to break apart. For fish and other aquatic species, the drying desert was not only drier, it was more isolated. Crocodiles are one of the clearest examples of what this fragmentation looked like in biological terms. Modern surveys show that relic populations of Nile crocodiles still persist in parts of Chad, Egypt and Mauritania, mostly in isolated gueltas and seasonal water bodies. The 2011 PLOS study notes that crocodiles had once been widespread throughout the Sahara until the early 20th century, but increased aridity combined with human persecution led to local extinction across most of their former range. In Mauritania, the remaining populations are scattered among mountain water points and often isolated within separate river basins, with permanent gueltas described as crucial for their survival. That makes crocodiles almost a living model of the drying process. They did not vanish from the Sahara in a single prehistoric moment. Their world contracted, split into refuges, and then continued shrinking under later aridity and human pressure until only isolated remnants remained. Many larger savanna mammals likely faced a different version of the same problem. The humid Sahara had supported open country herbivores, and in some regions large mammals, whose ranges depended on broad expanses of grassland and woody browse. As vegetation belts shifted southward and local water became less dependable, those animals would have had three basic options. They could track the moving habitats, survive in isolated pockets if the landscape allowed it, or disappear locally. That is one of the reasons the drying of the Sahara mattered so much beyond the desert itself. It did not only reduce local abundance, it displaced ecological communities. Animals that had once moved through North Africa on connected routes now had to retreat into the Sahel, the Nile corridor, mountain refuges, or other better watered margins. A greener Sahara had acted as a bridge. A drying Sahara restored the old barrier. Birds probably track the changing waters with more flexibility than heavier mammals, but even they would have felt the loss. Wetland birds can move, sometimes over great distances, yet breeding still depends on suitable nesting and feeding grounds. The humid period Sahara had supported substantial lake and marsh environments, including conditions good enough for local breeding in some species. Once those basins became less reliable, birds could abandon them more readily than a hippo could, but that is not the same thing as ecological continuity. The loss of central Saharan wetlands would have removed entire seasonal stopovers and breeding sites from the map. A bird leaving is a kind of adaptation, but it is also a sign that the place left behind no longer functions as it once did. Plants and animals that survived often did so in refugia, those favoured corners of the landscape where local conditions remained tolerable after the wider environment had turned hostile. In the Sahara, refugia could mean mountain gueltas, groundwater-fed depressions, sheltered uplands, or riverine zones with more persistent moisture. Modern crocodile populations in isolated water bodies are one example. The broader Green Sahara literature also treats the humid phases as times when habitats were connected, and the dry phases as times when populations became fragmented into favoured areas. That pattern matters because refugia preserve memory and biological form. A relict population is not just a conservation curiosity. It is evidence that the present desert still contains pieces of an older, wetter geography, broken off and stranded as the surrounding world dried. Humans, of course, had more choices than most species, though choice should be used carefully in a story like this. A fisher cannot negotiate with a shrinking lake. A herder cannot persuade poor grazing to improve through optimism. But people can change subsistence, alter mobility, reorganize households, shift seasonal patterns, and move when places stop working. A large demographic study based on 3,287 radiocarbon dates from 1,011 archaeological sites found that Saharan population rose strongly during the humid period and then underwent a major decline after about 5,500 BP, showing that climate was the prime factor driving broad-scale population dynamics in northern Africa. That does not mean every settlement vanished at once. It means the carrying capacity of the region was shrinking. The Green Sahara could no longer support people at the same scale or in the same ways as before. The decline was also uneven. The same demographic work indicates that the Central Sahara, and to a lesser extent the Atlas region, experienced a more gradual population decline rather than an everywhere abrupt crash. That aligns well with the paleo-environmental evidence. Some parts of the Sahara remained usable longer than others, particularly where local water, sheltered terrain, or residual vegetation delayed the full force of desertification. This matters because it reminds us that human adaptation was not a single exodus. In some places, people likely left comparatively early. In others, they stayed on, using shrinking resources more intensively, becoming more mobile, and relying on knowledge of refuges and seasonal access. The desert did not empty all at once. It became harder to inhabit and people adjusted along a gradient of difficulty. One of the most important human adaptations was pastoral mobility. As fish declined in significance and broad wetland-rich habitats contracted, herding became increasingly central in many areas. Takakori is again a useful example, because its long sequence shows how a site can track environmental pressure through changing use. The 2024 archaeobotanical study describes the final phase of Takakori's occupation as characterized by nomadic and highly specialized goat herders, with short-term and episodic use of the shelter, rather than the more prolonged occupation seen in earlier phases. That is an extraordinarily practical response to drying. When water and pasture are no longer broad and stable, you stop living as though they are. You become lighter on the land, more scheduled in your movements, and more selective about where and when you stop. The shift toward goats is especially telling. Cattle are valuable, but they are less tolerant of harsh aridity than small stock in many situations. As the Sahara dried, goat herding became a more resilient strategy in increasingly marginal settings. Archaeological work from Takakori and related studies in the Central Sahara consistently point to this later specialization in goats and more mobile use of shelters and mountain areas. That is not a romantic change. It is what adaptation looks like when a landscape that once offered wide, wet season and dry season opportunities starts narrowing its terms. The old grassland world made room for mixed economies, fishing, and broad pastoralism. The drying world rewarded thrift, mobility, and animals that could manage with less. There is also growing evidence that human activity may have interacted with this environmental decline rather than merely trailing behind it helplessly. Nature Communications published a modelling study in 2018 that tested claims that early pastoralists caused the end of the Green Sahara, and instead concluded the opposite. Pastoralism may actually have delayed environmental deterioration. The authors argue that the major population collapse around 5.5k coincided with declining climatic conditions, but their modelling suggests herders were not the trigger of collapse and may have prolonged favourable conditions in some areas. That is a useful reminder to keep the story balanced. Humans were adapting to climate stress, and their land use mattered, but the main force behind the shrinking Sahara remained the weakening monsoon and the changing hydrological regime. People were part of the system, not its sole author. As conditions worsened, movement toward better watered margins became increasingly likely. The University of Cologne summary of the Lake Yoa work notes that as the Sahara dried, many pastoralists and farmers retreated toward the present-day Sahel and the Nile Valley. Even without imagining a single grand migration, That general tendency makes ecological sense. The old wet corridors were collapsing. The Sahel still lay within reach of stronger monsoonal influence. The Nile remained a dependable river system. For communities whose knowledge, animals and livelihoods had developed in the Green Sahara, these margins offered continuity of possibility when the interior no longer could. Desertification, in that sense, did not only erase worlds, it redistributed them. Not every response was movement, though. Some places were held for surprisingly long periods by exploiting groundwater or highly local resources. Even in later dry phases, the Sahara was never absolutely uniform. Oases, deltas, and mountain-fed pockets allowed some continuity of human and non-human life. That is why archaeology in the Central Sahara often shows not a blank gap after the humid period, but changing site use. Shorter occupations, more episodic visits, more pastoral emphasis, less evidence of long-term fisher life ways, and in some areas continued ceremonial or funerary significance long after the environment had become harsher. The land was no longer broadly hospitable, but it still contained nodes of persistence. In a drying world, survival often means learning the difference between a landscape and its last usable corners. There is something sobering in how ordinary this pattern is once you strip away the prehistoric setting. When climates shift, life does not respond with one grand gesture. It sorts itself. Species with flexibility move. Species with refuges contract. Species tied too tightly to vanished conditions disappear locally or altogether. Humans do much the same, though with more tools and more memory. The Green Sahara did not end only because rainfall declined. It ended because a whole web of linked opportunities came apart. Water became less dependable, plants less continuous, animals less evenly distributed, and human communities more constrained in where and how they could live. A grassland becomes a desert not only when sand advances, but when the old network of life can no longer hold together. By the time the Sahara had fully returned to its desert state, much had adapted, much had moved, and much had vanished from the interior. Yet what survived still carried traces of the older world. A crocodile in an isolated delta, a pastoral route hugging the edge of better watered ground, a cemetery beside a dead paleo lake, a shelter floor layered with dung from later herders where fishers had once lived longer and more comfortably. All of these are remnants of the same long transition. They tell us that the shift from grassland to desert was not a single ending. It was a sorting process repeated across centuries and across different forms of life. And once you see that clearly, the ancient Sahara stops being only a vanished curiosity and starts to look like a very sharp lesson in what changing climate does to living worlds over time. Data place current warming in long-term context, help assess the role of human activities in ongoing climate change, and provide tests for climate models under conditions outside the range of recent observations. In other words, the old Sahara does not tell us that today's warming is just natural. It helps show why that claim is so weak. We can compare an ancient, orbitally forced climate transition with a modern, human-driven one, and see that the causes, pace and risk context are not the same. The pace difference is especially important. The humid Sahara developed and then faded over millennia, even though some local shifts within it may have been abrupt. That gave ecosystems and human societies more room, at least in relative terms, to adapt, move and reorganize. Today's warming is occurring over decades to centuries, with impacts already visible across Africa and elsewhere. The IPCC's assessments for Africa and for drylands emphasize that climate change is already affecting the continent, and that soil drying can intensify atmospheric aridity through self-reinforcing land-atmosphere feedbacks. That should sound uncomfortably familiar after everything we have seen in the Sahara story. Dry ground can reinforce dryness. Vegetation loss can alter moisture fluxes. The land is not passive, it reacts, and sometimes it reacts in ways that make the original problem worse. This is one reason the Green Sahara remains scientifically valuable. It is an out-of-range test for climate models. Recent climates, useful though they are, do not sample the full range of what Earth systems can do. The humid Sahara gives scientists a real case in which the West African monsoon reached much farther north than today. Vegetation expanded dramatically, dust emissions changed, and regional climate was reorganized. If a climate model cannot reproduce something we know happened, that is not merely inconvenient, it is informative. It tells researchers that important processes are being missed or underplayed. The Frontiers Review from 2024 makes exactly this point. Paleoclimate data are essential for testing models under conditions beyond the modern calibration range and for improving our understanding of key processes relevant to future change. The ancient Sahara, in that sense, is less a curiosity than a laboratory with very old equipment. There is also the matter of dust, which sounds dull until one remembers that dust is one of the great quiet agents in climate. The Sahara today is the largest source of airborne mineral dust on Earth, and that dust affects radiation, clouds, atmospheric circulation, ocean fertilization, and weather far beyond North Africa. Reviews of Saharan climate change emphasize that wetter conditions and more vegetation reduce dust emissions, while drier conditions and reduced vegetation increase them. During the Green Sahara, lower dust loads were part of the wetter state. During the drying, dust rose again as the desert re-established itself. That matters now because changes in Saharan land cover do not stay politely local. Northern African ecosystem changes can have remote impacts, and modelling studies continue to examine how Saharan greening or dust reduction could affect climate in distant regions. The Sahara, in other words, does not keep to itself. That has a modern echo as well. In recent decades, the Sahel, just south of the Sahara, has experienced significant wetting and regreening after the severe droughts of the 1970s and 1980s. But the future of rainfall in the broader Sahelian Saharan region remains uncertain under ongoing climate change. Reviews of the region stress that both climate change and human intervention, including proposed regreening or afforestation projects, could alter hydroclimate and vegetation, but they also emphasize that our understanding remains incomplete. That uncertainty is not a scientific embarrassment, so much as a reminder that monsoon regions are complicated. The Green Sahara teaches us that Northern Africa can change a great deal. It does not grant us the luxury of pretending we already know exactly how every part of that change will unfold in the 21st century. And then there is the human lesson, which may be the most direct of all. The peoples of the Green Sahara did not survive by being stubborn in exactly one way. They survived by adjusting. Some fished rich lakes, some built pastoral economies around cattle, and later more drought-tolerant small stock. Some shifted mobility patterns as the old wet landscapes narrowed. Many likely moved toward better watered margins such as the Sahel and the Nile Valley as the interior became harder to use. That does not mean climate change is easy to endure if one is flexible enough. It means adaptation is practical, costly, uneven, and often tied to movement. In that sense, the Sahara's human history is not ancient in spirit at all. It is a record of people dealing with shrinking ecological options, changing routes, and the need to reorganize life around water. That is not an outdated topic. The Lost Sahara also warns us against one of our favourite intellectual bad habits, which is to confuse what we are used to with what is normal. To us, the Sahara is a desert first and foremost. That identity feels so obvious that it can be hard to imagine anything else. Yet over the Quaternary, there have been many North African humid periods, orbitally paced and amplified by feedbacks, and over the past 8 million years, proxy records have identified roughly 230 such episodes. The point is not that the Sahara is secretly a grassland waiting to be rediscovered. The point is that climate states come and go, and the map we inherit is only one frame in a much longer sequence. That should make us more careful with words like permanent, natural, and inevitable. The Earth has a long history of rearranging itself, and landscapes are often less fixed than they look to a species with a rather short memory. At the same time, there is a moral difference between recognizing that Earth has always changed and shrugging at modern climate change as though it were therefore no concern of ours. The paleoclimate record is not an excuse for indifference, quite the opposite. It tells us that climate change can be powerful enough to reorganize ecosystems, migration corridors, and water availability on large scales. It tells us that feedbacks can amplify shifts once they begin. It tells us that dry lands can become greener, and greener lands can become dry, depending on how the system is pushed. Those are not comforting reasons to relax, they are reasons to pay attention. When the IPCC warns that soil drying can intensify atmospheric aridity in self-reinforcing ways and that changing dryland ecosystems face risks from water stress, habitat degradation, biodiversity loss, and wildfire, it is speaking to processes that have long precedents in Earth history, even if the modern forcing is different. There is another quieter lesson in the old Sahara, and it has to do with humility. For a long time, the idea of hippos, fissures, and cemeteries in the Sahara sounded improbable, because the modern desert is so visually convincing. The land taught us otherwise, but only after people looked carefully at sediments, pollen, fossils, isotopes, tools, rock art, and shoreline traces. The same habit of careful looking matters now. Climate change is easy to misunderstand when we treat any one season, flood, drought, or greening event as the whole story. The Sahara teaches patience with evidence. It says that landscapes carry memory, that first impressions can be wrong, and that the present surface is not always the best guide to either the past or the future. If there is a scientific virtue hidden in all this sand, it may simply be the virtue of not assuming too quickly that what we see now is all there ever was or all there ever will be. It also teaches something about scale. A person can survive one poor rainy season and call it bad luck. A family can survive several and call it hardship. But when the atmospheric machinery of a region shifts for centuries or millennia, you are no longer dealing with weather or even with a run of bad years. You're dealing with a new geography of possibility. That is what happened in the Sahara. Water moved, vegetation belts shifted, animal ranges changed, human communities adapted or relocated. What had once been central became marginal. What had once been traversable became forbidding. We sometimes talk about climate change today as though it were mainly a matter of temperature alone, one more number to compare from year to year. The old Sahara is a useful correction. Climate change becomes real through water, land cover, food webs, mobility, and the basic question of where life can keep functioning. And perhaps the most useful lesson of all is that Earth systems are alive with consequences. Change rainfall in North Africa, and you do not only change North Africa. You alter dust transport, vegetation feedbacks, atmospheric circulation, and potentially climate connections reaching into other regions. Reviews of the greening of the Sahara emphasize those far-field impacts, and even recent modelling work is exploring how mid-Holocene Saharan greening affected atmospheric circulation beyond the desert itself. The point is not that every blade of Saharan grass once controlled the weather in Europe while looking self-satisfied about it. The point is that regional changes can radiate outward. Climate does not respect our preference for tidy boxes labelled local, regional and global. It links them. The Sahara of the past and the climate of today both remind us that the Earth behaves as a connected system whether we find that reassuring or not. So what does the lost Sahara mean today? It means that the Earth can change more than our intuition likes. It means that dry lands are dynamic, not fixed. It means that feedbacks involving vegetation, dust and water matter. It means that paleoclimate is not just a museum of strange old worlds, but one of the best tools we have for understanding thresholds, model performance, and the risks of pushing the climate system into states outside our recent experience. It means that human societies have always had to respond to moving boundaries of habitability, though never with complete fairness and never without cost. And it means that when we talk about climate now, we're not talking about an abstract future. We're talking about the kinds of reorganizations that the Earth has already shown itself capable of, only under a different forcing and on a much faster human timescale. There is something quietly steadying in that, even if it is not exactly cheerful. The old Sahara tells us that the planet is not fragile in the sense of being unable to change. It is powerful in its ability to change. What is fragile are the arrangements we become used to, where the water is, where the grass returns, which roots remain open, which species can hold their range, which communities can stay where they are. Earth will go on revising itself. The question is, how quickly, in what direction, and with what cost to the living things caught inside the revision? That is why the ancient Green Sahara matters now. Not because it offers a comforting cycle that guarantees things will work out, but because it reminds us that climate shifts are never only about climate. They are about worlds. And so we come to the end of this long walk through a desert that was not always a desert, through lakes that dried, grasses that spread and then retreated, animals that moved, people who adapted, and a sky whose slow changes rewrote a continent. If you think about it, the Sahara has given us two lessons at once. One is historical. That much of North Africa was once greener, wetter, and fuller of life than the present landscape suggests. The other is modern. That climate has the power to reorganize the ground beneath ordinary life in ways that can feel impossible until they have already happened. So wherever you're listening from tonight, perhaps take a brief look at the land you know best and imagine it not as fixed scenery, but as one version of a longer story. And if this journey through the Green Sahara kept you company, soothed you a little, or simply gave your thoughts somewhere worthwhile to wander, I'd be very grateful if you liked the video and stayed nearby for the next one. For now though, let the desert rest. Let the old lake settle back into the dark and let the earth with all its patient revisions keep turning.